Welcome to this public meeting of the Geographical and Geospatial Sciences Committee of the National Academy of Science, Engineering, and Medicine. I'm Pat McDowell, co-chair of the GGSC. We're glad to have you with us in the room, watching the webcast, or viewing the recording of this session at a later time. Before we begin, I want to say just a few words about the National Academies of Sciences, Engineering, and Medicine, and the Geographical and Geospatial Sciences Committee. Next slide, please. The National Academies are a private nonprofit organizations that provide objective, independent advice on science, technology, engineering, and medicine. The National Academies were established at the direction of President Lincoln and have been providing these services to the country for over 150 years. They draw upon the expertise of volunteers to inform policy with evidence, spark progress and innovation, and confront challenging issues for the benefit of society. Next slide, please. The Geographical and Geospatial Sciences Committee is a standing committee within the National Academies. It provides a forum for innovative science, technical, and policy discussions on geographical theory and knowledge, geospatial data, mapping and spatial analysis, and the applications of these theories, knowledge, and methods to society's most pressing challenges. The committee was formed in 2022 through the merger of two longstanding committees at the academies, the Mapping Science Committee and the Geographical Sciences Committee. Our current membership is comprised of 16 volunteers from across the United States with expertise in physical, human, and economic geography, geospatial data analysis, computational spatial science, human mobility, climate change, and natural hazards. The members are Budendra Baduri, Stuart Fotheringham, Oceana Francis, Janet Franklin, Hendrik Hamann, Janelle Knox-Hayes, Kristen Curlin, Glenn McDonald, Marguerite Madden, Keith Mosbach, Elizabeth Root, Kathleen Stewart, Eric Tate, and Dawn Wright. The committee is supported by funding from the National Science Foundation, the U.S. Census Bureau, and the U.S. Geological Survey. Now I'm going to turn the mic over to my co-chair, Harvey Miller, who will continue.
Okay, thank you, Pat. I'm Harvey Miller, the other co-chair of the GGSC. In our meeting today, we will discuss the implications of the future of mapping for digital resilience, with specific focus on perhaps the most promising and yet disruptive of digital technologies for the future, geo-artificial intelligence, or GeoAI. Our program today will consist of 3 sessions and concluding remarks, and we'll have time for Q&A after each panel of speakers. For committee members and speakers in the room and on Zoom, please use the raised hand function on Zoom to indicate you'd like to ask a question. For those of you watching the webcast, you may submit your questions via Slido. There should be a Slido Q&A box embedded below the webcast. Please note that this webinar is being recorded and understand that any questions you submit may be read out loud and included in our recording. A link to the recording will be posted on the GGSC website within the week. Now I'd like to turn it over to committee member Kristen Curlin, who's a professor of architecture, information systems, and public policy at Carnegie Mellon University, and she will introduce our first speaker. Kristen.
In this opening session, we will first hear from Dawn Wright, followed by In this opening session, we will first hear from Dawn Wright, followed by comments and insights by Tristin Nelson, Renee Sieber, and Xiaowen Wang. I will briefly introduce each at the beginning of their talks, and longer bios can be found in a link below the webcast. Let me first introduce Dawn Wright. Dawn Wright is the chief scientist of the Environmental Systems Research Institute, a world-leading geographic information system software and data science company. She was appointed to this post in October 2011 after 17 years as a professor of geography and oceanography at Oregon State University. Dawn is joining us today to provide an overview of her work on digital resilience. Dawn?
Thank you very much, Kristen. So I'll wait for the slides to come up. All right, thank you. My task today is to provide some context and perhaps grounding for the discussion of GeoAI and the future of mapping that we're going to have today. It's going to be very, very compelling, I hope. And one of the things that I wanted to explain from the outset, since we're using the word resilience, that this is about digital resilience, but it's to be separated from a prior forum on cyber resilience that was at the National Academies. And this particular forum on cyber resilience was more about information security, cyber security, particularly if systems shut down in the event of a natural disaster or war. What are the implications for the nation's digital security? We're going to talk about resilience from a different standpoint today. Now, in terms of resilience, just to provide an overarching definition, resilience in general is the ability to deal with changes or threats, the ability to absorb disturbance or stress or catastrophe, the ability to recover quickly to a prior desired state. So these are all of the aspects of resilience that I think we've come to know from varying aspects, especially when we talk about making communities more resilient. We hear all the time about making communities resilient to climate change. We hear all the time about ecological resilience, even personal resilience, especially in the case of community leaders or community organizers. But what I'd like to do today is to flip that around a bit. If we want a resilient community, if we want a resilient world, we need to first start with resilient data, resilient tools, resilient platforms. So this is what I refer to as digital resilience. And especially since we've put so much time and energy and funding into gathering these data sets, into building these tools, into establishing these platforms, we want people to be able to use them. So we want them to be resilient through all of these changes and threats and all kinds of disruptions, so that those data, those tools, those platforms will persist and will continue to be useful. So that's the idea behind digital resilience. Now, these ideas of digital resilience, many of them are not going to be new to you. Many of them have been discussed in prior varying terminologies and discussions. And I think one of the first discussions of this was in a special issue of PNAS. Way back in the good old days of 2011, there was a special issue in PNAS on a spatial cyber infrastructure that Xiaowen Wang and I co-edited. Renee had a wonderful paper in that special issue, and that's where we introduced two other disciplines, the idea of a spatial cyber infrastructure and the important idea of cyber GIS, which Xiaowen Wang has since taken to great heights and to the effect, or for the optimization of many other disciplines. And you'll hear more from both Renee and Xiaowen to this effect later on in our discussion. When we talk about GeoAI, geospatial AI, and the future of mapping, of course, we're going to talk about generative AI from a broader standpoint. And it's really mind-boggling that the pace of change in terms of generative AI has been very, very hard to keep up with. When we think about when OpenAI released ChatGPT, that I think was just 5 months ago. And it only took 2 months for them to get to 100 million users. It took TikTok 9 months to get to that place. And I think we're all familiar with Sam Altman as the CEO of OpenAI. He testified before Congress just a few days ago, just last week, and was very forthright about some of the concerns, some of the dangers, some of the threats of generative AI, and we'll hear about this in our next panel. But I think we're all familiar with the headlines where this is concerned. It's coming to schools. It's coming for your job. It's going to DJ your music. The implications for the law. It's going to create black markets, fuel culture wars. All of these threats that are before us now, as we try to deal with this amazingly compelling, very useful, but also very just amazing technology, and the implications for the geospatial community, the geographic community. Where are geographers in all of this? What is GeoAI, and what can it contribute? How can it lead? How can it protect? So these are some of the things that we hope to talk about today. The other aspects of generative AI, of AI in general across all disciplines. I'm a Paul Simon fan, so I had to do a little riff on his Still Crazy After All These Years album. AI is still biased after all these years. And it boils down to these issues, and I'm sure we'll hear more from Renee on this, really critical issues. When we're talking about AI, when we're creating these simulations, when we are pulling together all of this information, who is in the room doing this? What is the intrinsic bias? What is the potential intrinsic harm? What is it that's getting prioritized? Who is training these data? What is the data that we're training with? What about the user interface? Who is building that user interface? What gender are they? What part of the world are they from? What perspective do they bring? When we're talking about a user interface, that's part of the UX, the user experience. So who is the UI UX for? What about the toxins, the hallucinations? How do we remove those? How do we recognize those? So many, many issues here. Now we could talk, in my view, we could talk about digital resilience for a very long time. I'm here to just give you a brief definition, some grounding in these principles over the course of 30 minutes or so. And there are many other resources. There was an article that I had the pleasure of writing for University of Minnesota's NCM magazine a while back, and you can get to that article at the URL that's on the screen. And there are also a couple of papers and talks where some of these ideas for digital resilience came out around 2015 and 2016. Let me just share with you 7. There are many of them. There are potentially dozens of these ideas or principles of digital resilience. But here's one. We all, I think, are very used to now making our data available. We're getting more used to making our code available. And this is very much in the geeky technical sense, but that's still not enough. That does not make the data or the code resilient. We need to be much more open about what we do with these data, how we implement this code, especially in terms of their intended uses. So this is just another way of saying that we need to share the workflows as well as the data, as well as the code. This is showing the scientific methodology that goes into what some of us call a virtuous chain or virtuous cycle. The example that you see on the screen is just a straightforward emerging hotspots workflow in terms of identifying hotspots of forest dangers in forests. So it starts with the data and what you do with the data. All of the spatial analytical operations that are performed on them, they go into a space-time cube. There's another hotspot analysis that's applied to that. And then hopefully from those results, you have a narrative that may take you in another direction or may take you back to the beginning again. At any rate, we have all kinds of workflows in our scientific work. This is a huge thing in geography and geospatial science. There's a move to share these workflows through digital object identifiers. We have those for data, we have those for journal articles. Why not for code and for workflows as well? A second principle is also not anything new about integrating, especially via interoperability and crosswalking. Many years ago, there was a lot of discussion about metadata, the data behind data, and crosswalking between different metadata standards. We tend to think about doing this now in a much broader universe that talks about doing this with spatial data, with sensor networks, with imagery and video, web services, big data collections, analytics, the analytical workflows, social media, even something as simple as spreadsheets. There's a lot of amazing science that is done on Excel or other types of spreadsheets. This should all be part of the equation. So to make all of these objects, items, processes resilient, we need to continue to work toward interoperability and crosswalking between them, various ways of doing this by using code that is explainable, and I'll talk about explainable in a few minutes. Something that's low code or no code is the language that's emerging there. Of course, open source, the open source world is extremely viable and useful and needed in this. Open specifications, open standards, directly integrating products. So here's just an example that we use at Esri, where I'm from, and this is all toward FAIR data. So this is hopefully becoming an acronym that we no longer need to explain, the idea of making your data, your workflows, everything findable, accessible, interoperable, reusable. And what you see in the upper right are some of the open source or open science tools and libraries that are our favorites at Esri. Also, direct integration of certain very valued platforms such as R and SAS, all of the ecosystem here of specifications, open licensing. I think we'll hear more about this in our third session. Also, to make something reproducible, to try to meet that gold standard of rigorous science, a great idea is to make it virtual where appropriate. So this is the idea of using these digital object identifiers to associate with data, certainly with open access journals. That's a nice, that is evolving, although the cost associated with open access journals is another issue, which makes them not as accessible as they could be. The idea of containers, where you bundle together a server with its operating system, with your database, with a Hadoop or a Spark data volume, just to couple those together, wrap those up, contain those, and share that with the user as a single executable. That is also something that's very exciting that's now on the horizon. A fourth principle here, I must channel Master Yoda. Master Yoda has said very famously, fear is the path to the dark side. Fear leads to anger. Anger leads to hate. Hate leads to suffering. I say also that ease leads to exposure. Exposure leads to adoption. So if we want people to use all of these wonderful assets that we are trying to make available, we need to make it easy for them to do so. But to make something easy is not easy. And we could have a whole session on that, but I wanted to just give as an example the idea of apps. Apps are wonderfully used and very popular among students, for example. There are apps that are being created by communities, women's groups, people of color, the various communities apps really resonate with them. And in terms of our educational evolution, how we're trying to teach our students, not just in geography, but in all disciplines, to understand geospatial, but to understand the world. We are teaching them to be users of technology, but we're also, I think, evolving to the point where we want them to be makers, not just users, not just adopters, but makers. And apps are a wonderful way to teach that and to practice that. A fifth principle is to make it explainable. And here I just want to highlight Renee's recent paper with her co-author, Jin Xing, The Challenges of Integrating Explainable Artificial Intelligence into GeoAI. The idea of glass boxing, making things transparent. I think it's related to the principle about that first principle about sharing workflows. And we'll hear more from Renee on that, I'm sure. And there is also a recent session on geography, according to ChatGPT, where several people in the room were involved in this session. Renee was one of the organizers. It's closely related to what we're going to talk about today. And I really want to point our community, those on Zoom especially, the URL that's in the picture there just takes you to the YouTube channel. You can find out from Renee all of the other resources that were associated with this very, very important discussion, the basics of foundational models in geography where generative AI and other types of AI are concerned. There's also hope in others who are working along these lines. Ye-Jin Choi is a UW, University of Washington computer scientist who just became a MacArthur Genius. He is working, the work that Ye-Jin Choi is working on is around giving AI common sense, if that's possible. There's also the work of geographer, Karen Bacher. She's from the University of British Columbia, and she is working on ways of communicating with AI, using generative AI to understand not only the sounds of nature, but to take that to communicate with nature in various ways, especially with regard to, of course, preserving and conserving it. We, as always, need to consider ethics, empathy, and equity. So here I want to, again, because oftentimes when I give talks now, I refer people to, I think, is what is a really substantive paper that Tristin Nelson was the lead author on, along with Mike Goodchild and myself in PNAS, in terms of accelerating principles of ethics, empathy, and equity in geographic information science, certainly from our standpoint of GI science, but from the standpoint of helping or collaborating or interoperating, crosswalking with other disciplines where ethics, empathy, and equity are concerned in their disciplines as well. And this is an open access paper. Part of this framework, especially in terms of equities, how do you actually implement this in software and in tools? At Esri, we have a very interesting and we hope a very impactful racial equity initiative where we are wrestling. You know, this is something else that is not easy. How do you work with GIS within a racial equity framework? How do you actually map and analyze equity? How do you, once you've got a start at least on that, how do you operationalize what works? What are those best practices? How do you understand whether this is working or not? How do you manage the performance within the traditional Western GIS framework that we all use anyway, especially as we're engaging with various communities of color or communities, gendered communities, all of these different perspectives, because the idea is to focus not on what we may consider to be authoritative data. A lot of our authoritative data, especially where communities of color are concerned, is wrong. What are those real lived experiences? What is the other context that we can bring to this to more holistically understand what the real barriers to equity are? And again, how do we do this within a GIS, particularly a very traditional Western GIS such as ArcGIS? How do we do that in ArcGIS? And we want to be able to do this. To that end, there are wonderful cross-discipline, cross-scientific centers and initiatives such as Xiaowen Wang's iGuide, his Institute for Geospatial Understanding through an Integrative Discovery Environment, that we will hear much more from him about in a few minutes. And one of the boxes that's within iGuide that provides wonderful resources is the Geoethics section of their website and of their activities that provides some great guidance there. But I'll let Xiaowen give you much more substantive information on iGuide. And finally, how do we use this seventh principle of promoting a culture, a workplace culture of sharing, of engagement, of collaboration? So this is one way to think about this, is enabling people, all different types of people. And in the graphic here, I'm just using the example of people with different job responsibilities, different levels of expertise within a company. Someone from IT, someone who's a human resource manager, someone who's in the field, someone who works with students or is a student, a lead scientist. How do you enable these various people with their different levels of expertise, their different backgrounds, their different perspectives, to work together, not just siloed in IT or siloed in human resources or et cetera? How do they work together, interleave together by securely sharing their data and their apps and their knowledge? So these are at least 7 principles to think of, and I hope it helps to further elucidate what we mean by digital resilience. If we want a resilient world, we need to start with resilient data, resilient tools, resilient platforms, et cetera. Hopefully we can think about this type of resilience, which does need to be exercised. And I think Renee will talk about this. All of this underpins a GeoAI that in turn is an inevitable part of our future of mapping. So the 3 on the left are more technical in nature, sharing not just data, tools, code, et cetera, but workflows, interoperability and crosswalking to make it reproducible, make it virtual. Those are technical ideas. On the right are more sociological, interpersonal ideas in terms of how do we make things easy and why do we want to do this? How can we make things really explainable, translatable, but also transparent, especially in terms of GeoAI and the broader area of ethics, empathy, and equity guiding all of this, which all 6 of these principles lead into that 7th principle of the culture of sharing and engagement and collaboration and inclusion and belonging and all of these good things. So these are some of the introductory remarks that I wanted to make. And if you'd like this slide deck, you can go to the URL. See, I'm practicing what I preach, making things as available as I can in the lower left. And my contact information is in the lower right. So thank you very much to the committee for having me kick off our discussion. And I defer back to Tristin. Thank you.
Thank you very much, Dawn. That was very... You set us up nicely for the rest of the day, and I am particularly interested in looking at GeoAI and machine learning, and not only the risks that it poses, but the benefits and how we can perhaps break down some of those silos with workflows and crosswalks and working with different disciplines, especially the community. And so I know that we have our three discussants that are going to not only talk a little bit about a reaction to what you've just said, but also share their own work and their own ideas about moving forward. So with that, I'm going to start with Tristin Nelson. Tristin is the Jack and Laura Dangerman Endowed Chair of Geography at UC Santa Barbara and is currently serving as department chair. Dr. Nelson and her team develop and apply spatial and spatial temporal analysis to address applied questions in a wide range of fields from ecology to health. She has studied mountain pine beetle infestations, grizzly bears, and environmental change. Currently, her research focuses on active transportation and the use of big data and analytics to better plan cities. So Tristin, take it away.
Thanks so much. Just closer. Thanks for having me, and thanks to Dawn for those wonderful remarks and for getting us set up so nicely. You never disappoint. It's always great. I wanted to pick up on some of the themes in Dawn's talk and amplify maybe a few points that are meaningful to me and the work that I've been doing lately. And, I think Dawn did a really nice job of talking about access and the importance of creating access if we want resilience in geospatial technologies generally, but I think AI specifically. And I think underlying that is the value of inclusion, and that in order to create systems that are resilient, I think we understand sort of intuitively that resilient systems do have a lot of diversity in them. So, I think that the example that came to mind when I was putting this talk together was because we just got a dog, and I was thinking about genetic diversity in dogs and how much this matters to health in the future. And so, this idea sort of filters through many of the things we do. And if we're thinking about generating geospatial systems that we lean on for knowledge creation, we also need those systems and our workflows and what we include in those to be very diverse. And so I'm just going to pick up on sort of two aspects of this, talking a little bit about data diversity, and then also how the geospatial community is really poised to lead in incorporating diverse perspectives into our work. So I think, in many ways, one of the major successes of geospatial has been the creation of data. We have so much data. I think 20 years ago, the amount of data and the variety of data we have access to now wouldn't have been imaginable. And if we then harness the power of AI to exploit that data, we are going to enter an era of all kinds of new things and new discovery. And while we can imagine a scenario where people might be working this data for evil, I think often we are working this data for good, but we need to be really careful about what some of the unintended consequences of the work that we're doing are. So, when I think about the opportunity associated with the integration of this diverse data with GeoAI, I think, well, we can answer questions and we can ask questions that are more nuanced and interesting and probably helpful than the ones we've asked before. And in my work in active transportation, the one I've been thinking about lately is the difference between sort of idealized maps or idealized access to, say, bike lanes and what is actually realized. So historically, maybe we've looked at who lives close to a bike lane, and that is considered access. But we know that's not real access. Real access is who lives close to a bike lane, owns a bike, isn't worried about being pulled over because they're walking on a sidewalk and being ticketed, is comfortable riding. And so when we integrate these kinds of data that we have access to now, we can actually answer those questions that we really couldn't before. On the other hand, there's lots of pitfalls. And so carrying on with this sort of active transportation data example, our cities in North America have been designed for cars. And so that means that our data assets have also been designed for cars. So if you are now an urban planner trying to plan for bicycling, you lack data. So you don't have good data on where the bikes are, how safe it is. All those data assets are very, very limited. And so we go about using some of our new technologies and new ways of collecting data to fill in those gaps. So my team has run bikemaps.org, which is a crowdsourcing tool for mapping bike crashes, because only 20% of official crashes are reported. So if you are trying to plan in your city, you don't really know what's happening. So we have this new crowdsourced opportunity. And so it's great. We're using technology to fill in some of those data gaps. And so in some ways, we are making our data more inclusive and more diverse. But The people who map on bike maps, they look a lot like me. So I'm like the classic demographic that's going to go on there and put my data in. So the result of that is, people who already have access are providing us the data that we're using to fill in the data that we're missing. So if we plan our cities, we might end up planning cities for me. And I am just one person that we might want to plan cities for. So while the effort is to make data more diverse, we are also creating these additional blind spots, which I think we need to be incredibly careful of, particularly when we send GeoAI to work with these data, that some of those missing gaps will be hidden, I think, if we're not really conscious of this moving forward. So the second thing I want to pick up on is just the opportunity to incorporate diverse perspectives. So I think as science, generally, we are thinking more about who's included and who's excluded in using science, in the generation of knowledge associated with the academy. And while we recognize that this is an issue, I think we're still just at the early stage of trying to figure out how to solve this problem. But I guess I want to give a shout out to why I think the geospatial community should be leading in this area. So this is an article that I wrote with Esri's Lauren Bennett from the spatial analyst. She leads the spatial analyst team. And we put out an article about why every data scientist needs a geographer. And in here, we had some things about the value of spatial perspectives and the additional information that comes in our data sets if we consider spatial. But we were also talking about how the interdisciplinary training of the geospatial analyst or the scientist really does create an opportunity to lead in terms of inclusion. The types of questions that we ask and answer are of interest to a wide variety of people and perspectives. The types of questions we could answer are even more broad and should be even more inclusive. And there's an opportunity as a geographer, as a geospatial scientist, to be thinking about, talking to ourselves, but also talking to the people that make decisions, talking to people in other disciplines, that we are really well poised in the sciences to be integrators. And as I think if we lean into that leadership, we will also be leading in incorporating diverse perspectives in unique ways, and maybe really authentic ways that we're struggling to sort of work our way through right now. So last of all, I wanted to introduce you to our lab stuffy, Dr. Normal. And I just wanted to take a second to use Dr. Normal here as a metaphor for maybe some of the ways in which we can inadvertently miss out on inclusion in the work that we do. So don't go too literal, please, with me on this narrative I'm going to give you. But most of you can imagine that most of the time the y-axis here is n. It's the size of our sample. But imagine if the y-axis was something else, cultural dominance or any particular trend or one way of thinking. Most of our research and our knowledge is generated around the bulk of the distribution. That's what we're focused on. And we often think that the tails, are less interesting. But I actually think that the tails are maybe where we have some of the most important information and knowledge that we need to be really considering if we want to create really inclusive research. In my case of bicycling, the tails may be an underrepresented group in bicycling who really wish they could bike, but don't have any access. And if we are not also incorporating their voice and their information into our data, we will design bike infrastructure that doesn't include them. So we have a variety of these stuffies, but this one sort of, I think the fact that, we lean so heavily on a normal distribution makes a nice metaphor anyway for the type of things we're talking about today. So that's it. Thank you so much.
Thank you very much. That was really insightful. And I think that I really appreciate the data science team needing a geographer. And I can't help but think that maybe they need a citizen as well, which leads us into our next discussant. Renee Sieber is an associate professor at McGill University in Montreal. She has 20 plus years experience conducting research at the intersection of civic empowerment and computational technologies. She also conducts research on natural language processing and computer vision feature detection. She currently researches public participation in GeoAI.
Right. I'm waiting for my slides to show up.
We are getting there.
Okay.
And I want to remind everybody that these are short bios. Look at everybody's bios in the webcast. Because I know you do much more than I just read 2 sentences about.
Dum 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 dum. Okay, great. Okay, so I thank you so much, Dawn, for your talk and your generous name dropping of all of us, especially me. I did not pay Dawn to do this. But thank you so much. So I'm going to talk about, well, whatever I could fit into 10 to 15 minutes. I'm going to talk about my reaction to Dawn's and Tristin's talk and Xiaowen's too. Next slide. So a lot of, no, there you go. So a lot of this is influenced by that workshop we held on geo foundation models. So you're going to see a lot of reflection on foundation models. On what's a foundation model? It is it's ChatGPT, it's Stable Diffusion, Midjourney, these sorts of things. So my first question is, before you're resilient, you must build it. Next slide. What does that mean? It means that foundation models and their geographic application is going to be pretty transformative, both with GIS, but also with what we think of as GeoAI. And we're rushing to try to figure out how we insert the geo in a meaningful way into the foundation models. One of the implications of that is that unlike traditional, it's kind of hard to say the word traditional AI, GeoAI, because it's such a new subject for us, but we're already at the point now with foundation models, we're building models atop models. So we're trying to integrate LLMs, large language models, computer vision models, knowledge graphs, the sorts of things that Sun Gao and Christoph Janowitz are doing to handle the semantics, the feature detection, the spatial and temporal topologies, and also things like Copilot that allows us to write the code to do those things. So to build a geo foundation model, we have to integrate all of those things. And Genqing Chen has actually written a paper, a research proposal for this integration, but it's super hard. We've just begun with GeoAI, and unfortunately, integrating knowledge graphs into GeoAI is almost trivial compared to what we're going to have to do with foundation models. Next slide. Okay, so to my question, who's going to build these GeoAI and Geo Foundation models? Foundation models, somewhat unlike GeoAI, because not all GeoAI requires data, if you're doing reinforcement learning, for example. But foundation models require enormous amounts of data. Who's going to acquire that data? Who's going to establish a repository for that data? Who's going to be annotating the data? And it's useful to point out that a lot of the annotation that's being done currently is being done in the global South. And ghost work is a geographic question that we should be investigating as we attempt to build geo foundation models. Who's going to Dawn's point, be building the user interfaces? Who's going to be doing the few shot or the zero shot to refine these models? Who's going to be implementing the reinforcement learning to reduce the toxicity in the geography? And I think a lot of times we think that if the toxicity is handled by generative AI, kind of the LLMs, then hey, it's just geography. Why do we have to worry about any bias? Wrong. So there's tons of bias in geography, as we well know. Is it the private sector? And in that workshop we held on geography, according to ChatGPT, we had lots of assurances from the private sector that, oh, are you kidding? Geographers, you're not going to be building these models. You know, just let us handle it. Just let big tech, OpenAI, handle this. To which I'd say, no, we cannot pass this off. But maybe Xiaowen will have the infrastructure that allows us to build the data repository so we can even begin to build these foundation models. Who's doing the audits? Who's doing the impact assessments? Will industry partners allow us to audit their Geo Foundation, their GeoAI models, or will they say, well, it's proprietary, and if we show you the probabilities attached to the meshes and the deep learning hidden layers, then we're going to be violating, or you're going to be exposed to, you're going to learn how we actually did it. Will we be relegated, geographers, to being passive users? And that is one of the implications of generative AI or GeoFoundation models, that we're not deeply interrogating the foundations of the layers, of the encapsulation. Instead, we're merely, maybe we're building a UI on top of GPT-4. To turn it into a conversational AI, to ask questions of it, as opposed to try to glass box the black box or the tiers of black boxes. Who's reporting and tracking the underlying intrinsic biases and extrinsic harms? Often when we talk about geoethics, we're talking about the extrinsic harms. Who's being falsely arrested as part of predictive policing? But the moment that we start using GeoFoundation models is the moment that we start baking in deeper and deeper these biases. Next slide. So there are lots and lots of impacts of GeoAI and GeoFoundation models. We've already heard instances of this is replicating whatever the data says. Ask ChatGPT to show you a bad neighborhood, a safe community, a middle-class area, and look at the color of any of the faces that you see in the images if you're doing, say, a text-to-image, or even if you're doing a text-to-text predictive modeling using a foundation model. Tristin already implied that it's all about the data, right? It's about data that is highly or overrepresented in these models and data that's underrepresented in models. So it's prioritizing, say, middle-class areas, but not poor areas. I should note here that I'm not advocating for a reducing data poverty. Indeed, I'm saying that there are some places in which you should not be representing. There are communities that wish to opt out, and we should also allow that in a foundation model or in GeoAI. Obviously, we can focus excessively on point data, but it's also linear data. So these foundation models can be predicting good paths to travel, bad paths to travel. It can be predicting where women aren't allowed to go. It can ignore local names. It can define communities without context. I'm thinking of like sundown towns, bulldoze towns, places that are on the wrong tracks. If you look at areas across the world, it can surface things that countries say, no, you're not allowed to show Nazi names of streets anymore, but yet it's in the foundation model and it's hard to get rid of. It's hard to reverse engineer that stuff. It will be interesting to see how foundation models, for example, design political districts in the US, considering that you live, I'm from Canada, you live in a vast world of gerrymandering, and what stops a foundation model from continuing that practice of, sure, I'll give you this squirrely salamander because that's what the data is telling me is traditional. Next slide. Oh, and before I go, okay, so where was I? Set slide. Right, so back to that slide previously. I just want to say that why do I have this picture of Tesla's beta version of their autonomous vehicle AI? It's because they're reporting that their AI is going to suggest if there's a pedestrian in the road, you don't have to slow the car down anymore because you know that the pedestrian will simply walk fast enough to evade the car. That's kind of like how foundation models work. It's the predictive model says the human being will get past the car. Do we actually want the models to work that way? I would say not. Also, during the break, I have a very interesting story about the Veterans Administration. So if anyone wants to ask me about that and how that might play out vis-a-vis foundation models, ask me. Next slide. Okay, so what are the intrinsic biases and extrinsic harm? I just want to say that part of the problem of geo-foundation models is that to this point about whether generative AI is going to create cultural domination and whether it's going to promote a universalizing of ideas and practices. So to this second bullet point, people have vastly different lives, economies, cultures, and world understandings not reflected in the output. We risk erasing the details of the global tapestry by unifying it under a singular algorithmic vision. We have an opportunity as producers and critiquers of GeoAI to introduce particularities, to introduce local context, and to reject this universalizing that is enabled by foundation models. And I would argue, as Bamasani did, he wrote a paper on the opportunities and risks of foundation models, that we have an even greater responsibility to do that. So this is not like the OGC days where, we just come together and we decide, what the geometry is, and we think about the standardization of that. It has much further implications for how we treat our fellow human beings in the global north, south, west, and east. Next slide. So finally, what are the ethics of GeoAI and GeoFoundation model? I could talk for hours, and I will not, about the problematic nature of ethics in AI. Most ethical frameworks are either what are called responsible AI, which are utilitarian ethics, or virtuous AI, virtuous ethics, which undergird codes of conduct. They're not red lines or rights-based, and we need to look at that. I could talk for a long time about soft versus hard law around this, whether we should allow companies to self-regulate or whether we should impose regulations on these companies. And we as researchers have a role in figuring out what the best approach is. I could talk about the limits of terms like openness and transparent, because it's not transparent to everyone, nor is it explainable to everyone. and as well as problematic terms like accountable, because accountable is often a fancy way of just saying transparent. And most of these words are to what end? These are a means to an end, and we should not merely be advocating for these things, but once things are transparent, what do we do with them? And that speaks to issues of raw political power that I think that we have to embed, whether we're doing the technical or the critique. And we have to look at things like meaningful participation in or with AI. That is my research in ways to move beyond the check boxes and the stakeholder engagements and the tech bros advocacy for AI for good. Hey, I know how AI works, and therefore I am the best place to understand the beneficial uses of AI. And I think we need to push back against that. We have a huge role, as I said, in grounding AI in place and rejecting that kind of transfer learning that universalizes AI ethics as usually done in responsible AI. But I will just end with one problematic nature of us relying on codes of conduct for AI ethic. Next slide. So codes of conduct currently, this comes out of GIS as well, is hey guys, just focus on accuracy. And if you focus on accuracy and completeness, then you will be ethical. And here is one reason why that can be highly problematic. You can, as a GIS specialist, as a GeoAI specialist, be very good in predicting when a pregnant person is getting close to a state border. And therefore, the police should be set out to arrest that person or the people transporting that person. So, hey, you complied with the code of ethics, but look at the danger that you place people in as a result of that, of just relying on virtue ethics instead of looking at instrumentalist ethics or deontological or rights-based ethics. And I will end it there. Thank you.
Thank you, Renee. You really have me thinking about a lot of things. And in particular, the foundation models and the speed of which things are changing and how AI is changing. But beyond that, I think beyond just us as geographers and geospatial experts, this has opened up a whole new area for people well beyond that, both in academics and in the private sector. And so we'll talk more about this and we'll have some questions, I'm sure. But, how do we start to regulate some of this with the speed of as things are growing? So I'm going to transition to Xiaowen Wang, who is a professor and head of the Department of Geography and Geographic Science and affiliate professor of the Department of Computer Science, Department of Urban and Regional Planning, and School of Information Sciences at the University of Illinois Urbana-Champaign. His research interests include geographic information science and systems, advanced cyber infrastructure and cyber GS, complex social and environmental problems, computational and data sciences, geospatial science and technology, high performance and distributed computing, and spatial analysis and modeling. And he is joining us by Zoom. So I think we're going to find his Zoom link. Thank you. Take it away, Xiaowen.
Yeah, thanks very much, Kristen. Let me share my screen. Hope you could see my screen. Let me put this into presentation mode. Is everything working properly?
Yeah.
All right.
Yeah.
Great. Yeah. Also, thanks very much to Dawn for that very illuminating opening talk, and really enjoyed listening to the insightful comments from Tristin and Renee. I echo a lot of things that have been said, and thought I would contribute a few more thoughts in the context of harnessing the geospatial data revolution for digital resilience. And very quickly, this is as a motivation for hundreds of years, three key modalities of scientific practice: experiment, observation, and theory. And only very recently, we had computational science introduced. This is for maybe 5 or 6 decades as a key modality of approaching scientific problem solving and discovery. And then, of course, more recently, big data, data science for a few decades. And of course, for this forum, the importance of AI in scientific knowledge production. And recognizing now we are closing this loop through a rapid digital transformation. And this is rather disruptive. And in this context, the development of CyberGIS, cyber-based geographic information science and systems, as Don was alluded to, is responsive to this digital transformation through combining big data to knowledge transformation, high-performance computing, and high-fidelity visualization and visual analytics, and collaborative problem solving together. And this is introducing additional frontiers to the field of GIS science. And together, the emergence of spatial cyber infrastructure enabled a variety of new scientific frontiers. And this special issue Dawn mentioned, she and I organized, really in today's view, scratched a little bit the surface there in terms of the possibilities and new opportunities and challenges for not only geospatial science, but also a variety of domains in connections to geospatial science. Fast forward, in 2021, NSF funded 5 national centers through the Harnessing the Data Revolution Big Idea Initiative. And in the context of geospatial data, we have iGuide funded as one of the 5 centers. And our vision is to enable digital discovery and innovation through harnessing the geospatial data revolution. And our mission is to transform convergence and geospatial sciences for holistic sustainability solutions. So my viewpoints are largely coming from the NSF iGuide Center. And this slide provides a summary of the collaborating institutions on the left, and on the right, the partners iGuide is working with. And the 6 components from iGuide we're pursuing to really have a set of convergent science catalysts enabled through geospatial AI and data science, supported by advanced cyber infrastructure capabilities and services on the left of this slide. And on the right, we are conducting a variety of education and workforce development programs, which I'll say a few more words. And we're engaging a variety of partners and to transfer knowledge with these partners and evaluate what we're doing along the way by engaging with broad communities. So how do we bring all this together? This is involving a set of disciplines, as summarized on this slide, over a dozen disciplines cutting across both natural and social sciences. And the key strategy here is really this iGuide platform to bring these different domains together. And this is very much, I think, in the spirit of digital resilience, as we've learned from Dawn through her very wonderful opening remarks and the talk. And also, as Renee was alluded to, this is a really experimental approach, right? Different communities, science communities have their own digital environments for scientific knowledge production. And a lot of problems iGuide is addressing in the context of sustainability science is really cutting across these domains. That means we need to bring together different digital systems and platforms together, including a variety of data sources that reside in different digital ecosystems. And this involves transferring data across borders of physical infrastructure or digital infrastructure, and figuring out how to make such data assets readily, friendly, available. Those were discussed earlier as well. And then really creating an easy to engage environment for different science communities for conducting convergence research. And the convergence research means research is tackling complex problems that are hard to solve by individual science communities or domains. So you see this kind of digital ecosystems as we're taking experimental approach to establish such a common platform. How do we assure the resilience of such ecosystem, as these are coming from contributions, diverse contributions from different communities, and bring this together to make them widely accessible to diverse communities, not only for scientific research, but also for education and for broader benefits to the society. So we're building this as we go. I think a lot of principles discussed by Dawn at the beginning, we're taking those into our experimental approach and also gain insights as to how such principles could be possibly transferable to parallel efforts such as ours. So the platform has a prototype, and on the left, for instance, you see some basic elements of this platform, including a variety of workflow examples that are executed on the national cyber infrastructure, and also focused on convergence problem solving, right? Such as assessing biodiversity loss across both social and environmental settings, and looking at aging infrastructure in the US, such as the aging dams infrastructure. So these are problems you will not expect a single scientific domain to come up with effective solutions. But also we have a resource catalog where you would have users without serious technical knowledge to be able to discover digital assets. And we also have resources for education and workforce development, which I'll mention in the next slide. So the link at the top, I would encourage you to go in there and try to break it. Give us feedback. As I was alluded to earlier, this is really an experimental approach to serve the purpose of enabling a variety of convergent science catalysts. I think one of the components of the platform is this convergence curriculum and its associated open educational resources. I cannot underscore enough the importance of the educational resources and innovation required to help us navigate through this extreme digital transformation and associated digital resilience we need to pursue. So this framework is led by Dr. Eric Shook from the University of Minnesota. He's co-lead of our education workforce development team within iGuide. As you could see this frame, from the very bottom, the foundational threads, including, for instance, ethics, was discussed quite a bit through this component of the program, and intersecting with the geospatial, you would derive geoethics, and of course, go beyond that is foundational to GeoAI and geospatial data science that is integrating with the domain knowledge, contributing to solving convergent problems. You see, this is from bottom up. And the argument here for this frame is that you really need flexible learning pathways. The traditional ways of configuring, let's say, 15 or 16 weeks courses or even fully fledged curriculum might not be adaptable to the very rapidly changing learning environments we're in today. So how do we have modular components, could be 3 hours or 3 weeks, centered around these components, enabling very broad, diverse communities to set up their own learning processes and pathways to gain the knowledge so that they're equipped to be ready for collaborative work addressing convergent problems, such as climate change, aging infrastructure. These are naturally geospatial problems, but linking to so many different communities. So we're creating this curriculum. Again, if you go to the platform, you see some early components implemented as part of this frame or this framework in general. And we would very much welcome your contributions and advice and suggestions, because this is only going to be effective through community-based contributions. And I want to give a shout out and also kudos to our iGuide team. There's this article on Directions magazine describing in the late term, what iGuide does and our team approach. So thanks to all the wonderful work to our amazing team. And with that, I'll wrap up, and my contact information here is on this slide, and be happy to take questions if we have time here, or follow up with me through my digital handles. Thank you very much.
Thank you very much. And I think that what you're doing is terrific. And I agree that this opens up to, again, beyond the experts. And how do we get participation of all of these topics for the betterment? So at this point, I'm going to open it up. I'm going to start with folks in the room. And also, if there are committee members that are on Zoom, if you would like to raise your hand. And I see that Harvey Miller has his hand up. So turn it over to Harvey.
I do. Thank you. And thank you, Dawn, Tristin, Renee, and Xiaowen for really a great opening. Great opening for this meeting. Really good, stimulating thoughts. Good food for thought. I want to talk about how we move this towards the good and avoid the bad. The example you gave, Renee, of the Tesla is a really good one, because that was not just a car avoiding a pedestrian. It was actually a pedestrian in a crosswalk where cars legally had to stop. So that was a case of AI that was designed to break the law, and yet someone on Twitter was cheering that. And I also think of the broader context in which we're operating. So, this meeting is about GI, future of mapping, in order to, create greater digital resilience in the face of the coming disruptions we'll see, such as those associated with the climate crisis. And yet we just had a test run of a major disruption, which was the COVID pandemic. And I remember at the beginning, things seemed to be great. It seemed like people were coming together, sharing data, trying to move towards the good, and that quickly went a different direction. So I guess I'd like to hear from all the speakers, what are the mechanisms by which we ensure we move this towards the good and do create digital resilience, and not move it towards the bad and create more exploitation, extraction, inequity, and so forth. I mean, I don't think it's going to happen naturally based on our experience with the COVID pandemic. So what do we do, I guess, is my question.
Embrace the messiness of politics and engage the public early. Slow AI, including imposing regulations, and geographers and others, research scientists, accepting accountability for the algorithms that they develop.
I would say also that this is a long game. To use your example, Harvey, of the pandemic is excellent, because I don't think people were trained, were exercised, and I'm thinking in terms of our physical. You work out. If you're running a marathon, you are prepared to run and train for several months in order to prepare for a 3 or 4 or 5 hour race. And I think our society, even in the context of the reward for our research, it's too short term. And I think in all of the principles that I talked about, everything that Tristin and Renee talked about, and even with Xiaowen, he received an NSF award, but it looks as though he is building a culture and resources that are going to last well beyond, let's say, a 5-year NSF award. So I think this tendency for us to build things or to set things in motion and then to move on to the next shiny object, or to get tired too quickly. It's like, well, I want this pandemic to only last for a year, because I can only stand things for 1 year, and I'm not prepared to change my life or to do anything beyond that. It has to end after 1 year. And of course, that's not the reality. So I think the long term has to be part of this as well.
I mean, I might just add, and I think this, relates to other things that have been said, is that the more people that are involved, in some ways, the better. So we can't, even if we lean on politics, I think we will see that it's going to be difficult to regulate this in a way that is perhaps satisfactory. And so I think, it's pretty nerve-wracking, I think, the moment that we're in right now. And I think because we can't control whose hands this technology enables, then we need to make sure that many hands are enabled.
Xiaowen, I think you have your hand up if you'd like to reply.
Thank you. Yeah, I agree with what was already said, but I'll add one point I think is more from our academic perspective in the higher ed educational institutions context, particularly here, to make some contributions in terms of the potential cultural transformation, meaning how do we incentivize the positive change? Because university systems in general are slow. For instance, making the digital assets more open and transparent and having institutional infrastructure to support that, university libraries, for instance, long-term institutional infrastructure that is needed to enable quite a bit of what we discussed today, and how the higher ed institutions could partner with industry, we have Dawn from the industry side, but it really pushing for policy change even within the university environment to help the next generation, scholars recognize the value and appreciate the importance of practicing, a lot of principles we addressed today. I cannot underscore the importance of doing this, writing tenure and promotion letters every year. I don't see much change in terms of the criteria being given. And how do we incentivize and conduct campaign to shift the tide? I think that is something the academic communities could do and could think about how to make the kind of impact we desire in this very rapidly changing world.
Thank you. We have another question from somebody in the room, Song Gao.
Yes. Yeah, thank you. The keynote and also the panelists shared their insights, and I appreciate one of the points raised by Dawn in her keynotes about the sharing culture, especially among the community, including the academics as well as industry. So one of the challenges we face, especially in building the foundation model, is that as researcher groups ourselves, it's very hard for us to train because of the accessible to diverse data sets as well as a large-scale cyber infrastructure, and also those industry regulation because of commercialization needs. So I wonder, in order to push this forward, and could Dawn and also keynote speaker share some of the insights, especially engaging the academics as well as the industry for collaboration in the GeoAI, especially like geo foundation model field. Yeah, thank you.
I'd like to invite my other panelists to respond, but from the standpoint of industry, and my colleague Andrew Turner from Esri is here as a director of a research and development center, and that is one of the primary ways that we interact with the academic community, as well as the role that I play in terms of being involved in specific collaborative research, being on NSF grants with researchers, but also to Renee's point, it's a provocative thing for a commercial entity to openly share the innards of a machine learning or deep learning model. And industry has to have the courage to do that. So that's one of the things that we seek to do at Esri, my colleague Andrew Turner developed our open data initiative. And Andrew, I'll defer to you to comment further on that. But how much money does a company need? I'm going to be really provocative here. Because when it comes to actual human lives at stake, or what is right for society, we have to take that path, and we have to open up as much as we can, especially with something as potentially dangerous as these, or the implications of these foundational AI models. Andrew, you want to jump in?
Thanks for the instigation there, Dawn. So yeah, I mean, I think I'll talk more about this later, but one thing that we see is that there's an old adage, a rising tide lifts all boats, right? The idea that by working better together. So Dawn mentioned open data for one. I also helped lead, amongst many other colleagues, an open source software initiative. One thing we realize as a company is the best way we can even succeed as a company, which every organization has its own motivations in terms of propagating its own ideas and growing, is actually by being open and collaborative and working with agencies, academia, other industry residents, right? Because many of us are both, you mentioned being a citizen on a panel, like, well, fortunately, we all are residents of somewhere. So we all have a role to play there. We all have communities we're in, so we can also bring that to what we work on. And the idea is by sharing these things, we can have better outcomes overall. So within that, though, there's a lot, right? So the interesting thing is with a lot of the topics being brought up this morning so far and later is really would be how to turn these into working hypotheses, projects we could collaborate on together, things we could try. And then I'm a big fan of short feedback loops. Share what we learned early, especially the failures where it doesn't work. So let's try some idea. Let's take some inequity issue and let's put it into one geographic area. Let's apply it in this community, in this community, in this community, and see what happens. Let's try this application domain and try it. So part of myself working in one of Esri's 54 research and development centers, many other companies have similar models, is there's a lot of potential for collaboration. But I would definitely, last thing I'll say here is recommend how to have focused experiments that are short feedback loops, are inexpensive, but we can learn quickly and then share that so we can iterate. If we would try and go with big projects, multi-year projects, that's where we start kicking into things like strategies and investments and intellectual property and all kinds of things, versus small experiments done quickly and shared can probably have better outcomes and be less risky or have less better outcomes.
And I think that gets back to, workflows again, Dawn, and how important the workflows are with all of this so we can replicate. We have another question from the room. Yiquan Shi.
Could I respond just
I'm sorry.
briefly to that?
Yes.
I think researchers can have a tremendous role in building GANs, in building generative adversarial networks. And to Xiaowen's point, building tools to break other tools, to test, to do sensitivity testing and other tests of tools. Obviously I'm interested in it from a community-based angle to detect bias, but I think that we haven't done enough, and we could do a tremendous amount in building these adversarial tools.
I just would love to jump in here too and connect a few things that I've heard. And one is that, well, it's bold for a company to make what they're doing public. I also think, to Xiaowen's point about tenure and promotion, it would be very bold for the academy to say we are going to value these interactions in a way that we can't, or we don't know how to credit right now in tenure and promotion. I mean, I think that we need some sort of flexibility around how we want to work together so that we can really create space for these collaborations to be beneficial and be motivated.
Yeah, you see that in so many research aspects where it's the research, but not the actionable changes. So very important. Okay, now we have another question from the room.
Yes, thank you. Thank you all for the wonderful talks. So first, I have two questions. So first is a specific question for Renee. So I appreciate your thoughts on seeing many people building models on top of existing foundation models and people building UI around these models. So what do you think the field as a whole need to do or need to improve in order to play a bigger role in terms of the GeoAI foundation models?
Wow, I could say a lot, but that is a really important and difficult question. So to some extent, we need people like Xiaowen to start building first the repositories and actually start building foundation models from scratch, and to compare the output of the foundation models we build and control, and also introduce things like traceability to figure out where, or attribution to the inputs to figure out why the outcomes are the way they are, and then compare those to the foundation models that are being built by big tech. So that handles the foundation part. And to some extent, I would be less concerned about building the UIs than I would be about furthering the knowledge graph work to integrate the computational ontological work into these foundation models. If you go to that workshop that we held, there was a lot of conversations about the ChatGPT getting the content wrong and then getting the location wrong. So one example was, is Washington in North Carolina? And ChatGPT said no. But then upon querying, ChatGPT was trained enough to say, yes, there is a Washington in North Carolina. Okay, where's the location? And location was wildly off. But of course, where those XYs coming from, and we assume that there's an analytic engine in the background that's generating those XYs. But of course, with a large language model or some facile integration, it really is, let's find some XY coordinates somewhere within one standard deviation of the content that we've decided to save, and pop those in. And that's not the way they can work effectively for us.
Yeah, thank you very much. And then I have another question that's a follow-up to this. So since there has been a lot of discussion about foundation models in the geospatial domain, so building the foundation models can be quite expensive. For example, ChatGPT may cost $100 million just to train after having all the data. So where do you feel as the field, again, we can get the resources in order to build our own foundation models for geospatial problems?
I could respond quickly. As someone who is in the audience of that Geography and ChatGPT webinar, one of the things that was brought up by one of the researchers, I think it was Mark Gagan, the University of Auckland in New Zealand, he brought up the point that some of this is going to be too big for academia. The resources are not going to be there. And this is another area where an academic industry partnership could work well. An industry partner, say like a part of Google or Amazon or Microsoft. At Esri, we can do this to a limited extent to share some of these resources and work together. Now, this is one of the things I'll let Xiaowen weigh in on this too, because something that's emerging that I see in NSF funds, NSF granting funds to projects that have strong industry partnership. So I think this needs to continue. The industry academic partnerships are sometimes not as well structured as they could be. And so that's an area, to me, that's an area of research. It's an area of research that some of our companies pursue. But I think that's part of the answer.
Thanks.
Xiaowen, before you weigh in, I want to add something that Mike Radcliffe just asked here. He's in the room from the Census Bureau, and that's that the conversation is focused on the roles of the academy and companies. But what do you see as speakers, the role of federal agencies, especially those producing these foundational geospatial data? So if you could perhaps address that as well.
Yeah, thank you very much. Now, is good for me to speak?
Yes. Sorry, yes.
All right. Yeah, I think just to build on what Don just said, it's very important to approach such large-scale foundational models from collaborative perspectives. The collaboration is broadly defined, between academia, industry, government agencies, and other types of organizations. And I think today's focus from our program is so timely and important. The notion of digital resilience should be the top priority as we approach such large endeavors, because it takes a village. Industry cannot do it well. Academia cannot do it well. Federal agencies cannot do them well. It really requires the village to come together. But digital resilience, this concept from Don, is really making sense, because otherwise it will be broken, right? Even if you could establish this, from siloed approach, it will be broken. It will not be resilient. I'll just quickly bring up two angles in terms of the value of the potential partnerships, the broad partnerships we were discussing. One is education workforce development. I mean, industry, other entities need the future workforce to be ready. And the other angle is knowledge transfer. And knowledge transfer is not a one-way transfer, it's multi-way transfer. And especially in the context of inclusive excellence and the representations we addressed, these are thorny challenges. You really need multi-way knowledge transfer, and also need the education workforce development to be ready for this very rapid change we're a part of. And I think that is a critical piece of the puzzle in broad-based partnerships. And you cannot do it. This will not be successful without broad-based collaborations. And the collaborations need to cut across all spheres in order to be digital resilient.
I would add to that it is important for regardless of the shape of the partnerships, it is absolutely critical for the federal government or any government agency to retain sufficient technical expertise to, at minimum, analyze, audit, understand, and explain these models. Too often, I mean, I mostly work at the local government level, and I hear CTOs say, well, all we have to do is outsource this stuff to the private sector. Well, if you cannot even understand what you put into the request for proposals, then you've got a big problem. So you have to have the data scientists, and to also Trislin's point, the geographer in these government agencies.
I see Mike has his hand up. Mike is from the U.S. Geological Survey.
Yeah, and thanks, Mike Radcliffe, for the question. I had some of the same ones going through my head. As the owner of a large repository of geospatial data and a large national geospatial program, those are the same challenges I'm faced with. And Renee, I was particularly taken by your comments and what you had in the chat. It's not that not only that we can't retain, we can't recruit. We don't have experts. We're looking with people that are trained in human geography, or myself as a spatial scientist, that are now being responsible with overseeing some of this translation. We put out job announcements for people that can talk in the GeoAI world, and we get 0 recruits because we can't afford them. They're going to private sector. They're going to other places where, frankly, the federal government we just can't afford to bring these people in. But that doesn't mean I'm not incredibly interested in what this technology is and what it could bring as a public service, based on or acting upon or querying the data that not just my agency operates, but have access to across the national spatial data infrastructure. So I'll dig into this a little bit tomorrow. We've got time in the sponsor brief, but I am really curious about how someone like me or my counterparts at other federal agencies can have access or can leverage this explosion in GeoAI, because I think there is tremendous opportunity, but we're struggling. I'll be frank, we're struggling with figuring out how it applies to us, how we take it in. We're going to have to look to academia, to industry, to be able to build those things. I hate to be often in the position of just the bill payer and just the person writing the checks, but that sometimes that's all I got.
There was a question earlier in chat that we think of AI as purely automated, but it relies on a huge number of human beings to either automate the training data or detect toxic content. And much of the human work is done in low-income countries like Kenya. Does anybody have thoughts or responses to this?
That was me.
Do you want to expand on that?
No, I want, I'll just say to shout out to my colleague in the city of Winnipeg, who has a PhD in philosophy and is a data scientist. So we're in this liminal period where some of the stuff is incredibly hard, but with software libraries, at least for machine learning, it's becoming so easier to do. So part of the problem when we talk about AI is we immediately go to deep learning and now to foundation models, but most all the AI we're doing is straight up machine learning. It's like Bayes and like random forest and the software libraries are really, really good now. And you could take a chance on a human geographer who's data or statistics curious, and I think do a lot of good things with that person. And we don't have to compete for, people who'd be going to OpenAI. Surprisingly, OpenAI had the same problems. Like, we can't afford to hire people. But I think we can expand our net of who's able to do these technologies now.
Thanks. I think we have time for one more question from Slido, and then we'll take a break. So the question is, following Dr. Wang's answers, since geospatial data is evolving so fast, building a GeoFM, especially for resilience purposes, means we need to update, retrain the FM more quickly than a general purpose model. Do you have any comment on that?
Maybe that's a question direct to me. So I'll say very quickly, one important strategy and almost a mandate in this rapid evolution is open scientific processes. I think this was addressed in Don's opening talk as well. And how do we have support and institutional backing to have such open processes widely made available, not only for research, but also for education workforce development? Because if it is open, it is beneficial to all in this evolution to enable additional innovation and also to enable trust.
Thank you very much. Okay, with that, I think that we are going to take a break here. So we have a break until 1:30. And so we're going to be discussing much more this afternoon. And I think that we all agree that this is going to be something that if in the next 10, 20 years is going to be something that we're really going to be addressing. And so thank you, panelists. Thank you, Dawn, for leading us off. And we'll see everybody back after the break.
Okay, hello, we are back. My name is Hendrik Hammann from IBM Research. I'm a committee member and I have the honor and privilege to moderate the next session. We have 4 fantastic speakers to talk and discuss the opportunities and risks of GeoAI. Each speaker will have 12 minutes, 3 minutes for questions. Any questions from the online audience should be in the Slido. After we're done with the 4 speakers, we have 15 minutes of more mutual discussions and more open discussion. Our first speaker is Yi Kwon Ji from the University of Maryland. He leads there the Geospatial Information Science. His research addresses challenges associated with AI around spatial data, sparse training data, locational biases. He's known for this phrase, one size AI does not fit all, which is sort of contradictory to foundation models, but I hope he tells us more about it.
Sure. Yeah, thank you very much. So it's a great pleasure to be here. I think there's some feedback. Okay, yeah. It's a great pleasure to be here to share my perspectives on GeoAI opportunities and risks for digital resilience. So since I have an interdisciplinary background, my PhD is in computer science, so I will mainly provide my thoughts on the technical perspective. So I'll start with, so I think the slideshow doesn't work if you can help. Okay, yeah, so I'll start with 3 research gaps and risks related to GeoAI, and then I will share some opportunities on that. So in many geospatial problems, when we try to directly apply existing AI methods, the success is often limited due to several interesting challenges. The first one is the well-known spatial heterogeneity. So I will borrow this nice example from Shashi Shekhar. The slideshow doesn't work again. Okay, it works. So in this picture, so we are trying to figure out which one is snow. So if you just look at the pictures, you see the patterns, visual patterns are very similar. So they have the blue sky, white ground. So it's a little confusing. But if you look at the locations, the first 2 are actually a salt lake and wet sands. Only the last one here is snow. So if you put this data for machine learning algorithms, it's going to be confusing for the following reasons. So whenever we try to make predictions for the target label Y, such as snow or not snow, part of the information is observed, for example, from the satellite signals, and then part of the information is not observed or very expensive to observe. So those information are likely not going to be a constant over space. So when you have those issues, in reality, you can have 2 locations share exactly the same observable features, but they are having different unobserved features. So their labels can be quite different. But if you put this in the AI model, they're going to give you the exact same prediction, which is incorrect. So this is the first challenge. And also we have limited highly localized data set. When you're trying to evaluate a machine learning model in a typical setting, you can see I have 80-20% trend test split. If you visualize that randomly in the space, it may look something like this. However, if you go to the spatial problem, many of them you have very sparse training data. So it's not as representative, and even more challenging, you often have it highly localized in some regions. And it's going to be very difficult to generalize those models to the other regions where you have not seen the patterns, and the patterns can be different from your localized region. So this is another major challenge. And beyond that, you also have the locational bias. So before, if you have an AI model with 90% accuracy, and you can be very happy with that, and that's going to be the end of the story. But today we know there are many implicit bias in those AI models. And so I have this spatial example. So supposing that disaster monitoring, and you have this difference in terms of the prediction quality in different regions. So overall, you still have 90%, but you see a lot of variance in different locations. Whenever you're trying to distribute the resources, maybe some communities is going to receive those resources due to the good prediction quality, but others, they're still very happy with the model, but others can be very sad and they can be hurt due to this implicit bias. So this is one example. Not only that, we also have this classic mob problem. When you're trying to look at, evaluate fairness of the AI models, again, for traditional problems, you have those well-defined categories, for example, different genders, different races, but in the space, we know it is continuous, right? So then we don't have the natural groups in there to start with. You need to partition the space. But whenever you're trying to do something like that, so here, let's say the green dots are the correct prediction, the red crosses are the wrong prediction. If you partition it in this way, and then left 2 has 100% accuracy, right to 0%. So this is unfair. But if you change the partitioning, everyone has 50% accuracy. This is fair. So is it fair or unfair? So you have this dilemma, which is connected to the classic MOP issue. So now that's enough challenges. I'm going to talk about some opportunities using examples that we have been doing recently. So for the spatial heterogeneity, we have this heterogeneity aware AI. So it's going to automatically, in your study area, it's going to automatically trying to figure out whether your data are generated by one single function or they're generated by multiple different functions. And then it's going to partition the space if your data is heterogeneous. And then it's also going to figure out how many partitions you need in your data in order to make each one of them homogeneous. So this is one framework. And you can see as you partition the space on the top, and then the model is going to continue to decrease the prediction error rate on the test data. So this is one example. More technical details are in the paper. So this one actually received the best paper award from IEEE International Conference on Data Mining in 2021. We also have the code public on GitHub. So now the code is a little complex, but we're working to simplify the code so it's easier to use for many other general problems. So the second, for the limited data, I think knowledge-guided learning is a very promising direction. And here, this is an example combining physics with deep learning. If you look at the physics mechanistic models, they often do not rely on a lot of real data. They rely on the certain physical assumptions. And in that sense, they have less overfitting issue. They are more generalizable. And it's the opposite for the data-driven deep learning model. If you have very small data set, it's not going to work. And when you have a lot of data, it's going to learn the patterns from the real data. It can surpass the performance of the physics-based model. So the idea here is to combine both. So you can have the model, you can have a better performance in both data limited and data abundant scenarios. So this is an example we recently worked on. In many applications, you have multiple physics models based on different assumptions. So this new meta-learning framework is going to tell you which models to use to combine with your deep learning model under different environmental conditions. So here is an example for water base flow prediction. So you can see the dots are the true observation. The blue curve is the prediction from a pure data-driven model, deep learning model. And then it's missing the peak right in here in the base flow. And if you combine that with the correct physics model under the right assumptions, it's going to recover this peak. So this is an example. And so this very recently got the best application paper award from SIME International Conference on Data Mining. And this is another example for knowledge-guided learning. So self-supervised learning is a very hot topic in the GeoAI foundation, in the general AI foundation models. The models may have trillions of parameters. It's not possible to have such a large annotated data set to train the model. So you need this so-called self-supervised learning. And here we are trying to supervise it with some domain knowledge on the spatial temporal dynamics. And this is an example for satellite imagery cloud masking. So before, if you have the ground truth, it's very straightforward to train the model. You just plug it in the deep learning framework. But here, if you don't have any label, there's no supervision you can do. And unfortunately, in most of the geographic areas, you have no label on the cloud. So here, again, we are trying to supervise it with our knowledge about the spatial temporal dynamics. So it doesn't require any human annotated labels. And if you look at the performance, so the preliminary result shows very encouraging results. So compared to the existing physics-based models, supervised learning models, this model without using any labels with self-supervised learning can sometimes outperform all the other competitors on different satellite platforms. So I have more details in the paper. So this is an area we're still trying to push forward. And then finally, I will talk a little about locational bias. So I showed you if you only have one partitioning to evaluate the fairness result, you have the dilemma of the MOP problem. So here, the one idea is instead of looking at only one or two partitions, you look at a larger distribution of different space partitionings. So that's going to give you a more robust and comprehensive representation of the fairness condition in your AI model. And the detailed training algorithms are inside this paper. And another interesting topic we're looking at is, let's suppose you're doing crop yield prediction and you have the model fair, you make the model fair for this year. But when you make the prediction for the next year, is it going to maintain the fairness? So that's a very difficult question. So here, what we're trying to do is to, again, compare the fairness aware model with the physics. So you have this crop yield physics model, and when you compare them together, it's easier to generalize the fairness as well. So this is an example. So before you consider the fairness in the yield prediction, you can see the prediction quality has very large variation over different counties. But now if you consider the fairness, you can see the prediction performance is more homogeneous across the spatial locations. So this is another example. So final slide is about my own thoughts on the future of GeoAI, again, from a technical perspective. So first, I think there is a need for a more solid technical foundation. We talk about GeoAI, but it's hard to think about what is really GeoAI. Is it just AI applied on spatial data sets, or there are some unique challenges with AI? You need the GeoAI to do something you cannot do with typical AI. So I think we need a more rigorous foundation in there. And also, I think we need some killer applications. ChatGPT is a great example, a killer application that everyone starts using. And today there has been a lot of vision talking about what's going to be the impact of ChatGPT on geography, for example. So those are really good discussion. But I think it's easier to say things than to do things, than to deliver things. So I think in the long future, to be helpful for the entire field, it's better to have some killer applications to show people this really works. For example, traditional AI doesn't work for my problem. And so my GeoAI, my foundational model is going to solve those problems. And so we need those applications. And finally, just my own thoughts. I think since we are talking about GeoAI and AI is a key word in there, I would love to see more participation from the field in the technical domain as well. So if we want to lead the development of these GeoAI models, I think we need to be at the core of AI as well. So participation can be, for example, attending those AI conferences and then submit papers in there. So in that way, I think the field can better engage with the general AI community. So, and then to play a bigger role in there. So that's on my slides.
Okay, so thanks so much. I think we have time for two or three questions. Please raise your hand. And yeah.
So maps lie.
Your mic. Can you turn your mic?
Sorry. Maps lie and remote sensing lies. So that's what Dennis Wood said in The Power of Maps. So how do you make sure that when you do these statistical comparisons between different satellites, for example, that you don't perpetuate the lying? So, for example, if you look at, I mentioned the wrong side of the tracks, there are reasons why people and activities are some places and not other places. How do we build that into the AI so we're not just furthering the prediction of harm and continuing the bias?
Yeah, I think that's a great question. So that's something we are actually looking forward to address. I think one issue we are facing right now is whenever we try to define the so-called bias and fairness, for example, and so it's more based on the technical definition. I want the model to have more equivalent performance over the locations. I will remove all the sensitive attributes, but how that is going to impact the final decision-making, how that will protect different communities, that's a harder question. So I think from my perspective, I want to have more discussion early on with the end users. I want to know how they are making the decision based on the maps generated by the remote sensing applications. And then based on that, we can come back and then redefine our fairness or bias definition. So in that way, we can have a more robust application directly towards the end user.
So next question, Javi.
Oh, yeah, thank you for your presentation. I appreciate what you're saying about physics-guided learning and how to basically make sure that the model behaves well over time and over space. But getting us back to disruption, which is really what the context is of this meeting, when we talk about human environmental systems, we're talking about complex systems that are going to be disrupted and possibly degrade over time. So will this approach be able to deal with those type of dynamics? Because those are more complex dynamics than you would see in a classic physics model.
Yes, that's a great question. So we also face the same issue. For example, when we one thing is when you're trying to make predictions for those extreme events, you have very sparse training data set in there in the first place. So when we try to directly apply the data-driven models in there, they often fail to recognize those extreme events. So one direction we are working on is to combine again with the physics models, which are not perfect, but they're better in terms of recognizing those extremes. And then to let the model be aware of when you are in the normal condition, we are in the abnormal condition. So then you can make better predictions. But if it is difficult for the physics-based model to recognize the extreme events in the first place, it's going to be very challenging to combine that with pure data-driven models, unless you have a lot of data to train the model. So I think that's something that's a really difficult question, still needs more work.
Okay, I think we have time for one more question. Maybe I can ask a question. So we had a lot of discussion about large language models, ChatGPT. Do you think that there's a fundamental difference if we look at other modalities beyond text and
Yes.
as it relates to the perceived power of foundation models?
Yes, I think that's another great question. So in my perspective, I actually think the text is a little easier to handle. So when we talk about training of these deep learning models, we need a lot of data. We need a lot of labeled training data. And then when you look at the language, when you look at the text, they're generated by humans already. So if you look at the Wikipedia articles, the books, those are written by humans. So in some sense, those already give you the labels. And then you can do the self-supervised learning. You can let it mimic the human behavior, give you a conversation or something. But when you look at the other modalities, for example, computer vision, if you look at using the pictures, you need the human to additionally label those data sets, which will greatly constrain the amount of training labels. And if you look at autonomous driving, for example, Tesla, they have been trying to work on these self-driving cars for so many years, and then they still haven't reached a status like ChatGPT, right? You can do a lot of the detections much better. They still end up in accidents. So I think for the other modalities, whenever you need human labels in there, it's going to be a much more difficult problem. So we are still yet to see the major success in those domains.
Okay, great. Thanks again for the fantastic presentation. We really appreciate. Our next speaker will join us remotely. It is Xiaoxiyang Zhu. She is chair professor for data science and Earth observations at the Technical University in Munich. Her research focuses on AI and data science of Earth observations. I think she has done some really interesting work on building 4-dimensional urban morphologies using GeoAI, and we're happy to have her here. Thank you.
Yeah, thanks a lot, Hendrik, for the nice intro. And I'm very happy to be here with you. Today, I will share a little bit my perspective, rather from Earth observation to the topic of GeoAI and the digital resilience. So I'm not sure whether everybody here knows Earth observation. We are mostly working with low Earth orbit satellite mounted with different sensors, and we make measurements of the Earth surface with different modalities. And in the last session, there was a discussion in the chat saying that the federal agencies, also space agencies, they are main, let's say, players also in the field of GeoAI to make the data available. From the Earth observation perspective, I would rather say we are in a golden age of Earth observation. This image is not showing how fantastic our lunch break is, but if you look at, for example, the European view of Earth observation, and you see here, besides the traditional meteorology and Science Explorer 9, we have the Copernicus satellite fleet, which is the game changer actually in the field of Earth observation, not only because they have this kind of mapping machines with different sensors mapping the Earth on a weekly basis, but also it has this kind of open and free policy, makes the data actually accessible to everyone. And here is just to show Earth observation is a big data par excellence. And this is just the data archive in the German Aerospace Center. So you will see today we already end up with about 50 petabytes of data. And most of them are actually from the Sentinels that are free and open. And until 2030, it will reach 140 petabyte. And in ESA, the plans for 2040 is already under discussion. So there is also a guaranteed long-term perspective for this type of data. And actually, according to a report from PwC, every euro spent in the Copernicus program ended up with around €4, mainly due to the downstream applications. So I think the whole field is blooming. And this, of course, then bring a lot of opportunities, what we call AI for EO for good. And on the screen, you are just seeing some examples from my own lab. For example, we are turning about 10 petabytes data to first ever 3D, 4D morphology of the Earth to better understand the urbanization process. We are developing AI methods to detect volcanic deformation patterns from the South American. And we are publishing data sets which can help to predict crop types and yield. And in the context of SDG, we are developing models and methods to map the informal settlements from the global south. And also we have a very strong thematic focus on delivering actionable geoinformation for climate change. What you see on the screen is the work we are doing for getting the glacier covering front. And also we are combining all this satellite data also with unconventional data sets like social media data to understand the social dynamics when it comes to pandemic or to analyze the sentiments and so on and so forth. To give two concrete examples of our own work, you know that in the past few years, we had a very hot summer, at least in Europe, and there is particularly threats for the elderly people. It's therefore very important to be able to understand where actually this heat islands is. Towards this, one potential tools we can use is the so-called local climate zones proposed by urban climatologists. Basically, it describes the morphology, compactness, height, percentage of green of the urban area. But what we have been doing with GeoAI is that we have derived the first global urban local climate zones classification. And basically, this is the map you see on the screen. Of course, much more interesting is the reddish areas. If we zoom in, then you can very nicely see where are the compact areas, where are the relatively rich areas, these orange areas, also the industry areas. Of course, with this data, it can help then to identify potential heat islands and also make adaptations and mitigation decisions. And also, this is a invaluable morphological data sets for urban area. If we do simple analysis by correlate this kind of morphology with population, then it's easy also to come to a global picture about inequality. So basically, based on analysis on 1,692 cities, we are able to figure out that 40 areas of compact, light, large, low-rise areas, which are apartment slums, they're accommodating about 60% of the total population. But if you look at the 30% area of sparse build, which are more houses, they're only accommodating about 10% of the total population of the cities were studied. A second example is more related to energy. You know that we are all experiencing the energy crisis. There is always the question about alternative energy resources. And one of the sustainable energy is the solar energy. And we have been asking ourselves, okay, if we would place solar panels on all the building roofs, are we able to basically accommodate the energy demand we have? So in order to do this, we need GeoAI because there is no existing global building footprint data available. And what we have done is that we have developed a so-called graph convolutional recurrent neural network and processed about 800,000 satellite images and come up with the building footprint across the globe. So on the screen, you basically see the availability of data of this, what we call global open building map, what is derived from GeoAI versus Google in red and OpenStreetMap in blue. This is a pseudo color image. Basically, all the greenish areas where you can see we can use GeoAI to close the knowledge gap. And then if we join analysis with the solar potential data, then we're able to get this kind of solar potential of every buildings. And you can see here the color indicates the gigawatts per year. And if we do statistics, then we can draw the conclusion. If we would place solar panels on the roof, we are able to supply 1.1 to 3.3 times of the energy consumption of 2020, which is actually the record in our history. 2021, 22, because of pandemic, it went down. And why there is 1.1 to 3.3, this basically depends on the, let's say, efficiency of the solar devices within the affordable price range. This is, of course, only a proof for concept study. In order to do more appropriate, let's say, decision-making process, of course, it requires much more in-depth analysis, but this is just to show the opportunities which is around with the GeoAI. Yes, so all it's about actually towards actionable geoinformation and the large-scale geoinformation that can directly support decision-making process. Towards this, there are actually still quite some open issues. Here is just the incomplete list of the open issues that my lab currently is working on. To give some examples, physics-aware machine learning. So in Europe, we have the agenda of Destination Earth, aiming at develop twins of the Earth system such that we can answer what if scenario. And towards this goal, very important is actually to combine the existing Earth system models with higher observational data and machine learning. Here, physics-aware machine learning is of course the key, let's say, challenges or key methodologies we should work on. And reasoning, for example, it's very easy for human, for example, to understand cars on the pavement, but it's actually not so trivial nowadays using AI to learn this kind of knowledge. So reasoning go beyond just recognize the semantics on the Earth surface, but also to explore the spatial temporal relations between semantics, such that we are able to derive higher level decisions or understanding higher level knowledge. Yeah, one example is, for example, to detect permafrost, where you actually need to have the context information about disturbances instead of identify permafrost itself. And another thing is about generalizability and transferability, because we are very often end up with a situation we have data-rich areas like Europe, like America, but actually our interest is more in the data pool areas like the developing areas. Also, because of the availability of sensor, sometimes we have training data available with the sensor A, but in the end, we want basically derive information from sensor B, and so forth. And one more important topic is uncertainty quantification. Since we are working with the Earth observation, we don't consider our data to be images. Instead, every bytes of the data we receive is kind of geodetical measurements. Therefore, it's not sufficient to just derive visual opinion results. Instead, we should be able to quantify possible uncertainties in the data, in the model, and being able to give alarm signals if there is out of distribution when we do the inferencing. And also explainability has been mentioned already before, but also bringing AI comes to, for example, how to get more labor efficient training, how to reduce the energy consumption of training model. Here, a lot of things has been already mentioned, like self-supervised learning foundation model and so on. Yeah, but also we need to be prepared for future computing infrastructure like quantum computers. And last but not least, but also ethics that has been mentioned a lot in the previous session. To give two examples, a lot of discussion is around natural language processing, large language models, ChatGPT. This is, of course, has also relevance in EO, going beyond typical visual question answering from satellite imagery or image captioning. Here is the ongoing work we are doing is called human-centered AI analytics of EO data. This means you can actually enter, for example, a natural language description, find all buildings with yard, then the model is able to provide basically image outcome from this kind of query. And ethics is another thing which has been mentioned, data bias, but also data privacy and also possible misusage, because with the big data and the GeoAI, we are providing unprecedented information, mostly open and free. Then the question is how to make sure this information will be appropriately used. And also, for example, for goodwill, we are providing global masks for slums, but already giving an area as a slum is already a social disadvantage for people who are living there. So how do we handle with this kind of situation? And this has been identified with as a very key topic in our, let's say, landscape, research landscape. For example, starting from 2020, we are running one of the 3 German international future lab on AI, and this one is on AI for EO. And we have identified ethics as one of the 3 main topics there. So the difficulties we have is that we do receive high-level ethical guidance from EU, for example. Yet, if we want to embed it to the daily research, it's very difficult. Our approach of doing this is more ethical, accompanying research, or better called embedded ethical research, having the, let's say, ethical expert already in the design of the problem in every step, try to develop approach to, let's say, address possible ethical issues, but more importantly, explore possible ethical opportunities. And here is a fresh tutorial paper we just published. For those who are interested, you're welcome to pay a visit. And also, all these are only possible if we are following the spirit of open data and open science. And one effort we are trying to do is basically provide a platform where we actually have all available EO benchmarks in the community, which is around 400 data sets on this platform with appropriate libraries and also deep learning models. Such that we lower the barrier for geographers, for example, to use GeoAI for different applications and etc. At the moment, we are trying to integrate also ChatGPT together with this kind of platform, such that actually the users can ask questions like, I want to detect wildfire. Then it will give you a recipe how you can use this platform and how to do that. Okay, that's probably my last slide. A few final statement. Basically, I would say EO is the important field of applied AI. And with these petabytes of data and also the GeoAI or AI for EO, it offers invaluable geoinformation that help shaping a sustainable future of our planet. But towards a large scale and actionable geoinformation retrieval, we still have a long way ahead. We need to address fundamental issues like uncertainty, physical consistency, explainability, transferability, and etc. Thank you very much.
Yeah, thanks so much for this fantastic presentation. A lot around opportunities. Since we're a little bit behind time, I think we skip the questions for the broader discussion. And then we go directly to our next speaker, Song Gao. He's an associate professor in geographic information science at the University of Wisconsin in Madison. He leads the geospatial data science lab there. His main research interests include GeoAI and combining it with the human aspects. He wrote a recent article on geospatial foundation models. And so we are really curious what you have to share. Thanks.
Yeah, thank you. So I'd like to share some of their thoughts about their opportunities and challenges about GeoAI and future of mapping. And I would like to start with a quote from my PhD member, Professor Helen Kokeles from UC Santa Barbara. She wrote an article about the artificial intelligence in geography in 1986. So it's not often that geography is touched by a development having the potential to affect substantially of all the aspects of our work. I think such excitement align well with different paradigm of the AI developments. So each of the booms, such as symbolic AI, expert system, until recently the machine learning, deep learning, and this year, the foundational models. So we have seen a lot of advancements, and also from previous talks about the AI in geography sciences, including but not limited to spatial scene classification from those high resolution remote sensory images or street view images, and geography object detection and localization, spatial induction and downscaling, especially cross-scale modeling, and spatial temporal prediction and modeling, and including both physical science and also human geography, as well as how to utilize multi-source and multi-model learning, and use, for example, representative learning, and to fill those all kinds of geospatial data, and also linking the physics or physical model with machine learning, deep learning to enable geographic discovery. So there have been a lot of open issues also we have discussed a lot today, and such as biases, extendability, ethics and privacy, reproducibility, replicability, and responsibility, and trustworthy, and last but not least, sustainability. So due to the time limit, I will just pick some of the topics and share my thoughts. And we do have a added book coming out about the handbook GeoAI, and a lot of authors here contributed and added by myself and Inje Hu from University at Buffalo, as well Wen Li from Arizona State University. And you may check out this book later. And in our work, especially for human perception over human environment, and for example, the perception of safety. So we may develop a GeoAI model, and by looking at those street view images. However, there are two types of biases existing in such a model. First of all, about the model bias, which may come from the data about who you sample from. Maybe there is biases, and as well as whether you train a global model versus this is localized, for example, neighborhood, which might deviate from the global model. And another type of bias is a perception bias. So this is really human play a role, because based on different personal experience or your local knowledge. So based on our study, we found that the results from the GeoAI model, by asking people, looking at the street view images versus actually the survey to the local residents who actually experience such neighborhoods, and they may have different knowledge and understanding about the safety perception. So you can see that when we apply such GeoAI model, from one region to another, there is such biases we need to pay attention to. So another issue is also linking to Yitrin's earlier talk about the spatial heterogeneity. So for science, we may require that, okay, the one developed model may be, replicate to another region. However, due to the spatial heterogeneity, as well as the heterogeneous distribution, we call the distribution shifts cross space and over time. So in the GeoAI model, we need to perform not only the within domain prediction as an evaluation, but also auto distribution assessment, because the results found that, for example, this is a land use map showing that if you train or look at the signal in winter in Wisconsin, Madison, you expect a lot of snow on the left versus you look at the signal in the summer, then no snow coverage, then the Earth surface signal is different. And then the figure on the right showing you that if you train a GeoAI model by looking at the satellite images in for example in developed countries from earlier years, and then when you do the auto distribution in later years and in developing countries, because the differences on the ecological, economical, and then cultural differences, also the process difference in the development process. So you will see a lower performance. So when you want to do the global mapping, so this also an issue we need to address. So another issue is about privacy. So because I do a lot of human mobility work, and the location privacy is always a concern, because utilizing the location data in model training, we may review the individual's privacy, such as their sensitive locations, such as home or other trips. And we may utilize generative AI, such as GANs, to generate synthetic data. And I'm glad during the break, I had a chat with Mike from US Sensor Brewer. We know that in addition to aggregated data, by introducing the differential privacy for the individual level data, we may need to use such a generative AI approach to generate the individual level synthetic data to meet some of the research needs. So moving forward, and because of the data regulation or data accessibility, so when we not able to access the individual level data, and we may need to shift our training paradigm. So instead of sending the data to center server, we may actually sending the model to the edge devices. So for example, through the federated learning framework, which is a privacy preserving decentralized training framework, and our exploratory work showing that, for example, for next location prediction accuracy, compared with over 90% accuracy achieved in centralized learning paradigm, we can actually achieve about over 80% accuracy. So compare with 90%, we sacrifice accuracy, but we achieve better privacy protection for individual users. So last issue, so it's about sustainability. So definitely about the future and then the digital resilience. We need to definitely consider those tremendous carbon emissions, energy, and the water consumptions in training those AI models, especially foundational models. And we need to, using the thoughts about intergenerational prioritization of how to utilize those resources across space and over time. So in 5 years ago, in our moonshot question, we asked, can we develop artificial GIS analysis that passes a domain-specific Turing test by 2030? So, surprising by recent development foundational model, we may actually achieve this goal maybe even early. So this is why now, we have a lot of work about the GeoAI foundational model that utilize multi-modal or large-scale geospatial data sets ranging from satellite images or GPS trajectory, also natural language description about places, and then geospatial semantics, and to enable the GeoAI foundational model. So I would like to share two of the exciting direction for me. One is the data discovery using the for example, ChatGPT to create such a GeoAI-enabled assistants. You may utilize the prompts to help you to navigate the data portals, for example, for those federal agencies. And the second is, now we can ask the ChatGPT about some of the classic spatial question. However, although it cannot answer you directly. However, if you add in those user prompts and then also telling the ChatGPT about where are your data hosted, and then you may actually be able to build an automatic GIS analysis workflow. So then you can, convert it, because you can generate those Python code, for example, by linking GeoPandas and other GIS functionality, and then achieve like the model builder fashion in the new way. So that is the area I'm very excited about. And we can also add in the user prompts for cartography. For example, this is an example done by my students, and to ask whether you can generate those different types of maps and across different regions with certain description. So using the DALL-E 2. But there are still some other issues, for example, inaccuracy or misleading information generated and unexpected features and tests on the AI generated maps, and also non-reproducibility, even for the same user inputs. So those are all, issues, and, looking at the future. So we need to really differentiate what is real, right? When we look at certain, geospatial products. So that's very, very important. So last slide. And when we want to develop GeoAI for future of digital resilience, we really need to utilize, first of all, intelligent cyber infrastructure, and also those various kinds of big data sets from center open source or from on-field sensors, and as well as integrating with foundational system AI techniques such as knowledge graph and federated learning or conversational AI. So, and also for such interdisciplinary efforts, we also need to collaborate with domain science to achieve so-called co-design user-inspired science. So this is also the core mission in the NSF funded AI Institute ICICL, which I participated. So with that, yeah, thank you for your attention.
Okay, great, Song. That was an excellent presentation, Turing test for GeoAI. I love it. So questions? Any questions? Harvey was the first.
Yeah, I guess I want to talk about the sustainability of GeoAI, and this relates to what Dr. Xu was saying as well. So when I think of sustainability, I think, of course, of environmental sustainability, but I also think of economic sustainability and social justice, which is the broader definition of sustainability. And I'm just wondering if we are going towards a world where we have the usual haves and have-nots, where some people can use these techniques, some places, some communities, and they'll be creating better community resilience. But while other places won't have the resources, expertise, money, computing capabilities, and they'll be suffering from the haves who are burning carbon and adding to climate change in order to solve their problems, while the have-nots will be suffering from the progress of the haves in this area. And that could be a classic global north and global south division. Yeah. So I'm just wondering if you could comment on that. I mean, how do we mitigate that? Are there alternatives to computation heavy AI that we can explore? This relates to the topic Dr. Xu brought up about green AI. So
yeah. Thank you, Harvey. This is a great question. So from the technology perspective, there are also some other companies, especially small size companies, they're also trying to develop such a lightweight foundational model. But for the broader question about sustainability, I think it's more about the equity and the communication, because, for example, for the climate risk adaptation or awareness, oftentimes it's because some of the marginalized or disadvantaged communities, actually, they don't have opportunity or, as you said, access to those digital technologies or advanced maybe AI, and to let them to speak or to make a voice. So this is why, through some of our projects, especially in the GeoAI, we found that actually, in order to engage those community participation, I think the communication is very important. This is why we need to incorporate science communication experts in the team to really make that happen. So that's actually was my takeaway from some our AI community engagement aspects. Yeah.
Okay, great. Thanks again. So we get to our last speaker, which is Bo Zhao. He's from the University of Washington. He's an associate professor in the Department of Geography. His research adapts a human lens towards these emerging geospatial technologies. And I think you've also done some really interesting work on geospoofing. And so I was not sure whether you're going to talk about this, but please go ahead.
Great. Thank you, Hendrik. Good morning, afternoon, and evening, everyone, depends on where you are. So what I would like to think with you today is the opportunities, risk, and the possible future of GeoAI, especially considering the AI can generate deepfakes, and Hendrik just mentioned the spoofing issue, this information data in a really uncannily realistic format. In my recent paper, I named such data after deepfake geography and discussed it in the context of a post-truth. And we think today that people have a different perspective on the trustworthiness of data, depends on their information they have, and also sometimes their emotion, and also they believe in the truth based on what they prefer. So have all those, I think it's critical. It's very critical, and also is a crucial, is an important moment when we are talking about the digital resilience of GeoAI. The rise of GeoAI has great influence on our life, society, and business, and how the government operates. For just the mapping, I think GeoAI have a myriad of potentials, like all other speakers has been mentioned. They can develop a spatial implicit model and help us understand and interpret the spatial and temporal and the spatial context of image. And also they can easily generate a life trajectory of celebrity or a historical event in the format of a GeoJSON or GML, which can be used for making story maps. But for sure, we need to double check the data accuracy, but at least they provide a foundation to start with. Also, they can help people to make geographical imaginations that doesn't, some of the imagination doesn't exist in the real world, like the movie Inception. So we can use DALL-E or Midjourney to help us to envision what is a mirror space, what is a folded space, and what is a twisted city or other imaginations. By doing so, they can free our imaginations from Cartesian space to a non-Cartesian space. So among all those possibilities or opportunities, my presentation mainly focused on the capability to generate those photorealistic, remotely sensed imageries, like the images that I show in these slides. They're all generated by Midjourney, a generative AI that can produce photorealistic image using prompts, like those images. Some of are portraying an urban landscape, a forest, or coastal area. If you are not a remote sensing expert, sometimes even you are, it's really hard to read, to know if they are legit based on your own eyes. So this technology has a lot of potentials to help us envision different type of landscape, how climate change may influence geographic area, and also visualize the boundary of city or forest, among many others. Although the capacity of GeoAI definitely worth to be celebrated, but it can also contain potential risks, especially deep geography I just mentioned. My team published a paper on this and has drawn tremendous attention from media outlets, industry, and academia. As illustrated in the slides, the three major geographical associations in North America has reported this work. Deepfake geography in a narrow sense describes a photorealistic satellite imagery that has been forged by GeoAI in order to illustrate a landscape that doesn't exist in the real world. That image, under most circumstances, cannot be distinguished by human eyes. So here, why is deepfake geography or deepfake in general a risk? I know some of you might already watch this. Last Tuesday, US Senator Richard Blumenthal delivered an open statement at a hearing on AI with text written by OpenAI's ChatGPT and audio generated by a voice application trained on his speeches on the Senate floor. The real Blumenthal delivered a severe warning after the statement. What if, he said, the recording has been used to fake an endorsement of Ukraine surrendering or Russia President Putin. So I mean, as the senator mentioned, this could be a really serious issue, and the technology outpaces the regulations. And some people don't know it is no one, in fact, could tell that it was a clone. So does the deepfake remote sensing imagery. As warned by, I know Kevin is here, as warned by the former CIO at the National Geospatial Intelligence Agency, deepfake geography is the newest AI-enabled weapon. Using his own word, the deepfake photos of the Earth. He also expressed urgency to study deepfake satellite imagery, as he indicated some countries are already doing it right now, using GANs, which is a typical generative AI, to manipulating things and pixels to create things for nefarious reasons. So it is a time to think about ways and take actions to detect fake satellite imagery. As a researcher, to better cope with the deepfake geography, we need to first understand how this image is generated. And also we need a large collection or benchmark of deepfake satellite image to learn their features that are not easily distinguished by human eyes. So we use multiple generative AI to generate a benchmark of deepfake geography satellite imagery. Considering time, I will skip this slide, but if you have questions about this technical process, we can bring up in the Q&A session. Using this technology, we generate a satellite image of different platform cameras. like Google Earth imagery of different zoom level, Sentinel-2, Landsat-A. As you can see, these images are so realistic. Our lab have using 500,000 images to reach a realistic level like this. In our research, we proposed a support vector machine approach to detect deepfake cellular imagery. It learns 12 salient features of deepfake cellular imagery, which are ranging from the spatial domain, color, histogram, and the frequency domain. The results is pretty good. We reach F1 score 0.95, which taking all the 12 features into consideration. So for next step, we're thinking about to make the GeoAI more resilient or better dealing with the deepfake geography. We think maybe we can develop a non-fungible token-based cellular imagery licensing system that can track the authenticity all the way from its generation. Secondary, we're also thinking possible. Is it possible to develop an API to detect the authenticity of satellite imagery, like how Twitter notifies the trustworthiness of a tweet? Another approach is to build a scientist-led public-facing platform that allows people to share their own opinion towards the authenticity of satellite imagery. We're thinking of doing this because we believe that rather than merely depend on algorithm to dominate our understanding about what is true and what is false, it is more important to allow people of different opinion to offer their own interpretations of the ground truth to discuss and debate. In the future, in addition to those previously mentioned technical approaches to consider the risk of GeoAI or the deepfake, and to make it more digital resilient, I think it is also necessary to understand the diverse interpretation of geographical data, trustworthiness, especially the role of the AI in the when they use interpreting the trustworthiness. For example, in the indigenous people's cyber protest against a crude oil pipeline that plans to be deployed across a tribe land, people over the world are using fake checking. Checking is a typical online locational information on social media to show their support or solidarity to the on-site indigenous protesters. As shown in the checking information on the left, that user showed in the post, in the checking, he said, "I'm here in spirit." So they believe the data is true support, but traditional media, the pipeline company, they believe the checking are fake as they were not standing there. They are not there in reality. The most important is the AI, the recommendation algorithm. Usually the commercial AI are black box. We don't know how it runs. But even though we can see that if the AI doesn't treat the checking as true, the spoofed location cannot be spread from a small number of protesters checking to their follower, to the followers to make this event really big globally. So in this example, there are different interpretations of what is true and false, even toward the same geographical information. The example implies that when examining the trustworthiness of geospatial data, no matter it's locational information or remotely sensed imagery, we need to examine who are the stakeholders, how they interpret the truth differently, and what their power status, and how they influence each other. It is a better AI literacy that can enhance the digital resilience of GeoAI. So in the future, another tendency of GeoAI, if allow me to have a bold guess, is the democratization of GeoAI. GeoAI will be very popular and be used by multiple stakeholders, and I hope the potential democratization of GeoAI could benefit the marginalized community to develop their own AI solutions. But we should be also keenly aware that this tendency may also enable a large community to use AI for their own goals. And I'm very concerned about the malicious usages like the deepfake geography. To grapple with such malicious uses, I think AI governance and marketing regulation will be very important. But in addition to that, in the future, what is the responsibility of us? I think above all, we need to be aware of the dual role of people as both AI users and AI developers. It is because nowadays that even in the foreseeable future, a person would be pulled into the creation of the AI intentionally or even unintentionally. For example, why unintentionally? If you are a smartphone user, for a lot of those location-based apps, if you don't turn off your location track function, and most people don't, or turn it on unintentionally, your data will be collected and will be used to train the model to improve the algorithm. Like how some of the apps use it to fine-tune the cycling routes, right? So therefore, facing the dual role, we can advocate for facing the dual role as both user and developer. I think we should actively advocate for both AI literacy and AI ethics together. The AI literacy will enable us to be aware of the bias, the distortion, the deepfake. The AI ethics will enable us to apply AI for social good and use it responsibly. So overall, in the future, I think, which probably is a post-truth era, as I just implied, I think to make a digitally resilient GeoAI, a humanistic rewire is crucial. To get a human in the loop, to get a society and a community in the loop, which I quoted Renee Sieber's words. And this approach will take into account human perceptions, experience, and interest. By prioritizing the human value, cultural context, and social impact, GeoAI system can be developed and utilized in a manner that is more inclusive, empathetic, and aligned with social values. I think that's all.
Yeah, thank you all. Excellent presentation and some really fantastic thoughts at the end, especially how to move forward. I think we have time for one specific question, and then we broaden it. It seems like Renee she's the first. Why don't you go ahead?
So this occurred 4 hours ago on Twitter. A fake from Ben Collins, a fake Bloomberg account with a verified blue check on Twitter posted an apparently AI-generated picture of an explosion at the Pentagon this morning. There was no explosion at the Pentagon, but the stock market still dipped. So here we have today an example of deep fake geography. I guess I've talked to you about this before. I still am really, I don't like the word truth in your title, and maybe at most, and you're qualifying it, but maybe put quote marks around truth. Like, I'm very ambivalent about doing that, because I know we live in a very divisive society and where we want to talk about facts, and you can't have your own facts. But we've lived in eras in which the truth was controlled by a very small number of people. We live in an era in which we can be incredibly technocratic with AI and say, well, just let us handle truth and deal with post-truth. So I don't know if there's a question there, but how do you handle the fact that there really wasn't a truth, but yet we want to talk about facts?
Thanks, Renee. I think we talked about this, but again, it's a really great question. Actually, I think for a long time, because when I started working on this with the supervisor of Harvard Miller and my advisor, that I have a struggle of using the word that truth in my work and the fake. Because truth, as you just mentioned, the difference between fact and also for fake, there is a strong emotion in the words as well. So how to get rid of those preconditions is always hard tasks for me. That actually somehow driven by some of the phenomenologist theory that how we can go back to ourselves in addition to have prejudges like using the word truth or even fake. Also, maybe somehow relevant to your question, I also think about using the words legit, authenticity, trustworthiness. They could be used for different scenarios. And by seeing that, I guess, in the reality, I realize that all those are the words people are using, and we need to pay attention to why they're using these words and how they are using what the context. And especially for those historically oppressed community, what are the words they use and how we can better provide our humble opinions to interpret these words. I don't know whether that's a question, but this is general. I thought this is definitely complicated, and we need to pay attention to those differences. Yeah, and also try to get rid of those preconditions. Look at what is you guys using the word fact. Yeah.
So I think unless there's specific questions, I think Dawn, I saw your hand up, and Harvey, we can have the broader discussion. Yes, this more broader. Your comments, your questions. Yeah, so then maybe we start with you, Dawn. Next question, we go to a broader discussion. I just want to remind everyone, and I'm not being just here, but we had a relatively technical perspective initially, right? Then we heard a lot about these opportunities of GeoAI. I think there were some really good examples. The Turing test, and now we heard about post-truth GeoAI, the handling of that. Anyway, I want to give it to Dawn for the next question and discussion.
Thank you, Henrik. I absolutely loved each and every presentation in this section. It was just outstanding. Thank you to all four of you for this. And I wanted to use Bo's characterization of democratizing GeoAI. I think that's in a way that's very radical, because I think AI and GeoAI are seen as something that's very hard, very computationally intensive, something that is not for everyone, something that, for instance, human geographers wouldn't be able to relate to, something that communities would not want to have in their hands, especially if people are used to leaving things to big tech, as Renee has brought out, or the varying levels in trust in our government, or trust in our agencies, which the hope is that that would be something that those are all virtuous. They would be virtuous institutions, but in this new era that we are in, I'll just say it's divisive. This divisiveness. I'm just wondering from any of you on the panel, what are some of the ways that we can get marginalized communities involved in terms of making, to my point earlier about being makers of these models, of these foundational models, makers of perhaps these applications that are able to detect these deep fakes. And I'm thinking also in terms of Professor Zhu's wonderful presentation about these large Earth observation data sets. Where do we start with democratizing all of this? Thank you.
Yeah, thank you, Dan. This is great. Oh, sorry. Oh, yeah. Thank you, Dan. This is a great question. So, because actually the documentation of AI is part of also our slogan in the ISICO, the AI Institute. So I want to share two thoughts. The first thought I already mentioned is about really co-design or user-inspired science. So for example, in one of our AI application is about digital agriculture. So we need to actually reach out to, for example, farmers, and then to deploy those AI model to see whether they can work, also whether, for example, the model training another farm can apply to this farm, and also whether they can contribute to the data to the model training process. I think this is a co-evolving process that can bring the community into the process. Second is to really develop those plug and play AI like ChatGPT. So if we can make those plug and play AI like how we use electricity or water, and then I think that is the pathway to make the AI or GeoAI more documentalized. Yeah, I think that's my thing.
I think Xiaoxiang wanted to comment too, right?
Yeah, okay. This is actually a very, let's say, multidimensional question to answer. To democratize in GeoAI, on the one hand, for the more, let's say, users, it's more about to lower the technical barriers by sharing open source code, open data, like what we did with USNet to build up kind of platform such that there is the very easy and technical entry for the long, let's say, computer scientists more or less get into the field. But there is, of course, much more when it comes to the involvement of, let's say, underrepresented groups, more or less be part of the, let's say, research or these kind of things. This, on the one hand, as already mentioned, trying to engage the stakeholders where we try to make a difference. For example, a lot of people try to push GeoAI for social good. We put our focus on global south and try to deliver, let's say, geoinformation basis for better decision-making process. But often we start with kind of, let's say, a top-down approach without talking to let's say, the local stakeholders at the first place and try to better understand actually what are the information that are necessary in order to basically help with the, let's say, planning, decision-making process, and so on. So this is already mentioned, but there are also other aspects, right? Like how to basically work towards label efficient GeoAI. I mentioned the big data archive we have with tens of petabytes of data. But it end up with a dilemma. Everybody try to start with the big data archive and try to reinvent the wheel, train everything from scratch, and so on. Of course, this costs a lot of, let's say, energy when it comes to the model training and so on. That's why there's so much effort. They are trying to basically using kind of self-supervised learning, train general representations of the data from very big data archive, such that everybody can start from this kind of model instead of from scratch. Or there are a lot of effort now goes to the direction foundation models to train a model have representations across modality, across different tasks. This is another way of lower the let's say, requirement to get a decent model for real world applications. But there is also another aspect, even though we have the trained model and everything publicly available, still people from the global south, whether they have the resource to do the own inference and so on. This is not, let's say, guaranteed. That's why it's also important the whole community, not only developing fancy models, but also really try to go to the end global product with quality assurance and so on, that people can directly use them. Yeah, these are my answer to your questions.
Short comment, Bo?
Yeah, may I also, yeah, thanks for the thoughtful question. I actually think about this for a long time, but even today, I don't still have a good answer for it. I think the marginalized community, they are actually already participant in the GeoAI, as I just mentioned, even unintentionally, like if they leave their locale track function on, turn on, this participant help with the data gathering and model training. But I also think about some of the efforts where have been doing, like reach out and work with BIPOC college. I think this effort is great, but I also worry about the possibility to generate additional emotional labor to the people who are reached out. By saying that, I guess maybe the most important is that when those communities rise and spark their voice, I think as us, we have more resources. We need to be humbly and to be very acutely to aware those voices and wage in and to helping them with the powerful computer resources or expertise we have. So I think that would be really important from my perspective. In addition to that, I'm always an advocate for Tristin's work on the 3 E's, that how we can be more humble and even to ourselves and to the work we have been doing. And we need to continuously think about who are left behind and who we can get involved, their data, their behavior, and how we can model them and make sure that GeoAI can represent them. So yeah, that's my thoughts. Yeah.
Kind of a short comment. So very short. So I think that's a great multi-sector question. So since the question is from Don, I think actually the private sector can play an important role in here. So as my own example, so Esri has done a lot of AI for social good work. And then recently we had some support from Google, who connects us with some non-government organization, and they're working with people in Africa. So for those communities, if they want to use AI, it's very difficult. So they cannot directly reach out to me. But through the NGO, through the support from Google, we are able to work with the local community. And so we are using AI to help them to recognize where are the low-income areas, so then the local government can distribute the resource to the people in need. So I think so there's an important role that can be played by the private sectors.
Okay, so I think we have time for one more question, Harvey. Yeah.
Okay, thank you. I want to talk about how we can use GeoAI to democratize science and also evidence-based decision-making. And I think that's a cornerstone of having a resilient community, is where people are feeling engaged and as you mentioned, Song, are involved in a co-design process where they don't just hear the results of analysis and pick one of these options, but actually are involved in identifying problems all the way through the process. And I want to suggest something that could be used to bridge this gap, and that is storytelling, because people have lived experiences in the real world, while planners and decision makers work with data, charts, maps, things like that. And there's a real language gap between those two domains. Now, Dawn, in your paper on digital resilience and community resilience, you mentioned storytelling as a way of creating, engagement and more resilient communities. So I guess I'd like to hear about that. How can we use GeoAI to kind of translate between these two worlds in which people operate in communities and planners and decision makers operate? Can we, for example, gather stories from people and translate that into evidence? And can we take evidence and translate that into stories that people will resonate with people, so that we can have true communication and co-design? I'd like to hear your thoughts about that.
Who wants to go first? Yeah, Xiaoxian. You.
Yeah, thanks a lot for this question. I think this is a super relevant question. So climate education, science communication actually are become much more significant, particularly when it comes to evidence-based, let's say, decision-making, hypothesis test, and so on. In Munich, at least, we are now actually having a dedicated professorship just for this topic. At the moment, we're discussing ideas like how we can use GeoAI in combination with system models. Basically, people can play around with the parameters in a way GeoAI can visualize the potential features with our environment that we're familiar with. Yeah, I think there's a similar effort also from the AI community, where they will try to basically visualize in the next 30 years or 40 years, if we are more exposed to extreme event, flood event, and how basically the cities looks like, and so on. So this kind of interactive way of, let's say, communication or kind of storytelling may actually evolve for more, let's say, layperson for the topic. Yeah.
Okay. Any other comments to that?
Yeah,
Okay.
maybe a quick comment
Last
to Harvey's question is, I mean, ChatGPT is actually one thing can help is communication. And think about that, how we used to program. We need to write code and we need to debugging with a very close eye of finding where's have one extra period. But using ChatGPT, I guess, is really great communication tool for those who are not able to know GeoAI, can also build a really powerful models or functions that could make in fact impactful consequences. So yeah, I guess how to better using this unstructured is natural language processing to dealing with non-structured language and make sure people can communicate. That's really makes things different. Secondly, I also aware that the Hugging Face is a great tool that even sometimes for different communities, they are not able to have the capacity to develop our own, training their own, making our own GeoAI, but Hugging Face actually provide a plan for that. You can somehow to fine-tuning your parameters and make your AI for yourself. But in the meantime, I want to share with the experience of story maps that we try to get involved those local communities in the coastal area to know what is the coastal science about Cascadia region. But the one thing I think the story map we developed is pretty communicative and information, good information. And also we integrate the knowledge of indigenous people who live in Cascadia and long way before the settlers are here. But the issue is that when we're sharing this story map to the local communities, we found that the hardware is not sufficient, is not powerful enough. They cannot play the story map. So I guess to be aware of those different aspects that sometimes we take it for granted is also important for more effective communication.
Okay, so I'm afraid time is up for this session. We meet, first of all, we all should thank you guys again, right, for these fantastic presentations. I will meet back in 10 minutes or 15 minutes.
8 minutes.
10 minutes, 8 minutes.
If we're staying on time.
Okay, 8 minutes. Thank you.
Thank you.
So welcome back to our final session of today. This session is titled Resilient GeoAI, Exemplars for Basic and Applied Science. In our next session, we will hear from 4 speakers about examples of resilient GeoAI in basic and applied science. And two of our first 2 speakers are on Zoom only, and then our final 2 speakers are here in person with us. So each speaker is going to speak for about 12 minutes, and then we'll have a 3 minutes of specific questions from the committee or the webcast audience. After all 4 speakers have presented, we will have 15 minutes of more questions and a broader discussion with all 4 panelists. So I'd like to introduce our first speaker of the day, who is online. Our first speaker is Manil Maskey, Senior Research Scientist with NASA. He leads the Advanced Concepts team within the Impact team at Marshall Space Flight Center and Science Mission Directorate's Artificial Intelligence Initiative at NASA headquarters. His research interests include computer vision, visualization, knowledge discovery, cloud computing, and data analytics. So take it away, Manil. Thank you.
Thank you for that. Can you hear me?
Yes, we can hear you.
And can you see the slides that I have?
Yes.
All right. Thank you for that. And thank you for having me today. So I'm going to talk about GeoAI from NASA's new initiative on open science, how we envision advancing GeoAI using the open science principles. So this is my obligatory slide. So this is what Earth Science Mission Fleet looks like from NASA. It has the world's largest collection of Earth observation data. And this vast collection is driven by our mission, mostly research mission to understand our planet as a unified system. So these observations cover all major disciplines within the Earth science. That includes land, atmosphere, ocean, cryosphere, and also the human dimensions, all of which are geospatial in nature. So if you look at just the timeline here at what is coming up in next few years, you can see the high volume data missions here, right? It is just too much data that is beyond manual capabilities in terms of doing the science, developing applications. So basically what we're trying to do here is rely on this mostly more and more in data-driven technologies, and that includes the artificial intelligence. So at NASA, we have a new initiative on open science, where we're looking at GeoAI and any AI, artificial intelligence, from various aspects, mainly these 4 that I'm going to touch on today a little bit: policy, infrastructure, research and application development in collaboration with our partners, and then the community side of the things. We have this holistic approach because to fully realize and do the practical, not just the research on AI, but to put that into production and do practical AI, we need to consider this as a holistic system, right? And use the wider adoption of open science principles to drive some of these pillars of open science. So first, let's talk about the policy. NASA Earth Science has had a policy of free and open data for any purpose for the last 2 decades plus. And now we're moving towards the open science. How NASA defines open science is a collaborative culture, which we heard about quite a bit today. That is enabled by technology and empowers the open sharing of data, information, and knowledge within the scientific community and the wider public. This includes historically underrepresented community as well. So along that line, NASA recently developed its open science policy, which is called the SPD 41, that provides the guidance in terms of open science to our community. So that's the first thing regarding these major components. So next, it's a little bit slow loading here. The next component is the cyber infrastructure development, right, which is a major part of this open science initiative as all, and which is very relevant to the GeoAI component. With the migration of NASA Earth Science data into the commercial cloud, there are more opportunities now to leverage native AI services that are at different scales, that helps us put research into production, allows easy integration to exploit community expertise. It's not only on the cloud side, we are also investing quite a bit on the high-end computing side in terms of actual model training, and also lowering the barrier into getting into the environment such as high performance computing. So this is an exemplar application that you see on the left side of the chart. This is a project called Veda, which brings in key NASA data sets next to these open tools and services in cloud native environment, which in turn allows us to do multiple fusion of data sets and also apply artificial intelligence to develop this application like this, where this is in this case, the aftermath of Hurricane Ida in New Orleans. There were news articles about certain communities recovering much slower than other, which correlated with the certain socioeconomic aspects of that particular region. So the cyber infrastructure component facilitated this development of this type of application development, where GeoAI was a major component of it, right? And earlier I heard about the storytelling side of the things. The infrastructure not only allows you to do the research, but also put it in this form, which is not publication ready, but it allows you to convey the message to the general public fairly easily. So next is the community engagement part. From that perspective, NASA has started a 5-year mission to accelerate the adoption of open science. This includes training resources to enable broader participation from historically underrepresented groups and facilitating major scientific discoveries using the training aspect of it, right? And there is a real funding behind this, and we are well into the implementation of this effort, which is called the Transform to Open Science. And also GeoAI is a big component of this as well. We also engage with the community in different ways to address some of these open science aspects, like reproducibility and reuse of data, AI models, training data sets, and also the workflows within the GeoAI. And we are leveraging community-developed tools to achieve that. This is an example. In the middle, you see a Radiant Earth ML Hub, which provides a standard-based catalog of training data sets, models, with the goal of being able to reuse that to advance either the benchmarking aspect of the model or developing learning or transport learning kind of approaches, right? This is really helpful when we know that AI is advancing at such a rapid pace. We can't expect to do everything in-house within NASA, right? So we're trying to leverage community as much as possible. And one example of that is you see on the right, where data science challenges can be run and community can benchmark their own models based on the training data sets and the initial benchmarking that we can provide. So one project that I wanted to highlight is from Tucker and Brent, which you see here. What their team did is remarkable here. They mapped individual tree crowns in this arid Sahel region of Africa. When you think about it, we don't really associate having trees in this part of the world. But with the help of high-resolution satellite images, powerful deep learning-based AI algorithms, massive computational powers, and manually created large-scale hand-labeled these training data sets, right? They used those to train AI algorithms, and they were able to map billions of trees in this region. What this allowed is the quantification of carbon stocks in that area, the distribution of these trees, density, the cover information, ground cover information, and the carbon content is very not well known in this area, in this rural area. So this this information is very important for ecological protection, climate variables like carbon accounting, and also mitigation and restoration effort in the future. Right. So this is this type of research is from NASA perspective. This is one of the biggest open science win for us, right? Because if you look at the advances that this particular group made, the open science played a major role in this, right? In every aspect, including data, infrastructure. There's a major collaboration across agencies in terms of infrastructure. Obviously, the algorithms were open source algorithm. There's a plain, simple unit-based algorithm. Obviously, the open source software community as well, and of course, the investment for large-scale research like this. So the other aspect I want to talk about is the research and application, especially in terms of leveraging the partnership effort. In most cases, to do large-scale research like this, I'm going to talk about is we try to leverage our partnership activities, right? Especially with the industry and the academic folks. So one such area that we're leveraging our partnership right now is the foundation models. I heard about that earlier as well. So very briefly, foundation models are these large-scale models that leverage the self-supervised learning approaches, meaning that the algorithm does not need labeled samples to learn from, but rather it learns the representations of the data, which can then be utilized for multiple downstream applications. And much of these advances in foundation model is based on this transformer-based architecture. So you might say why foundation model we chose to do with the leveraging our partnership activities. We ran a workshop in early 2020, which highlighted the main bottleneck of supervised learning and the availability of large-scale machine learning training data sets. I think we talked about that earlier as well. Another issue that was highlighted was this generalization of GeoAI models in space and time, which are critical aspects of geosciences, but they don't really generalize when model to model, right? So we think that the foundation models are primed to address these particular challenges. So the question is, can we build a foundation models for domains and representatives for a particular domain using representative types of data sets? And this is our approach, right? You have one foundation model using some different data sources that can be used for multiple applications. So this is how we envision our end users using the foundation models, fine-tuned for multiple downstream tasks. This is a demonstration put together by IBM. NASA and IBM collaborated to develop a geospatial foundation model on one of the NASA's flagship datasets, the harmonized Landsat Sentinel-2 dataset. This demonstration shows that geospatial model can be used for multiple downstream tasks. In this case, floodwater delineation, burn scars, and crop type classification. And we're able to beat the state of the art in terms of these particular tasks, and also use very few labeled samples to fine-tune the foundation models. But the problem here is that the computational resources required to build such a foundation model is not feasible within the current NASA resources, right? Using the current NASA resources. And that's the reason we partnered with IBM, where they contributed their computational resources and expertise in developing these models. So as we move forward, we envision leveraging our partnership activities on these basic AI research collaborations and try to develop these kind of large-scale models for various tasks in the future. So I want to leave you with this final message that shows our approach to GeoAI using open science principles, where we strive to make science data more meaningful and support a more equitable, impactful, and efficient scientific future. We truly believe that our community participation in these activities are going to be key, including the partnership activities that we are very focused on moving forward. Thank you.
Thank you, Manil. We have time for one quick question. Yeah. Yes.
Thank you for the talk. So since you are talking about open science, and I'm interested in the foundation model you mentioned just now. So is that publicly available? Can we download the weights and the data used to train the model?
Yeah, it will be available in Hugging Face in near future.
Okay.
Yeah. You can just contact me using my email.
Okay. So to keep on time, we're going to move on to the next speaker. The next speaker is Catherine D'Agnazio, Associate Professor of Urban Science and Planning in the Department of Urban Studies and Planning at MIT. He's also director of the Data and Feminism Lab, which uses data and computational methods to work towards gender and racial equity, particularly as they relate to space and place. So I'd like to welcome Catherine. Thank you.
Great. Thanks so much. I'm just getting my screen organized here. Do you hear me okay?
Yes, we hear you.
Okay, great. There we go. So yeah, thanks you all, and thanks to Charles for the invitation to be here with everyone today. I really appreciate it, and I feel like I've learned a lot from the day's event. So here for me, I'm going to post some questions that come out of my own work on data justice and data ethics, but I think build on a lot of questions that have been raised today. And then since this is a panel on exemplars, I'm going to have an exemplar. So first, while I'm currently coming in from South America, I still want to thank the Wampanoag Nation and the Massachusetts peoples on whose lands I'm typically a guest, and on whose lands I've conducted most of the work that I'm talking about today. So I wanted to use my time today to raise some questions that Lauren Klein and I posed in our 2020 book, which is called Data Feminism. And I think these are questions that are relevant to our conversations about GeoAI and resilience today. So a little bit of background about this book. At the time that Lauren and I were starting to write Data Feminism, this was like in 2018, the world was sort of starting to wake up to the fact that data, big data, and AI could be a tremendous form of power. So we'd begun to see how data could be used for tremendous benefit. So things like advancing medical discoveries, directing disaster responses, providing evidence at scale. But we were also becoming aware that data and data-driven systems can result in significant harm. And specifically, I'm thinking harms here related to racialized communities, to Indigenous communities, to women and women of color in particular, to trans communities, to low-income families and workers, and so on. And at the time, and even now, still, I would say, the popular press stories, the way these stories come out, they often come out with this air of surprise about there being bias and discrimination in these systems. So, you know, things like, oh my goodness, how could a soap dispenser be racist? Or how can a resume screening system be sexist? But Lauren and I, and then along with many other people who work in disciplines that critically examine power, and these are disciplines like women and gender studies, critical race studies, Indigenous studies, decolonial and post-colonial studies, critical geography, we were not surprised. We have not been surprised by any of this. So for those of us who examine the long-standing and durable structural inequalities that exist across our societies, it comes as no surprise that the racism and sexism and colonialism that exists already and produces social inequality, why would that not show up in our data sets and in our data systems? It would be extremely surprising, in fact, if the reverse were true. If our data sets were magically, free of bias, that would be incredible. So, garbage in, garbage out, as they say, right? And so kind of the motivation for data feminism was to try to connect some of these dots for people, as well as to outline strategies to prevent our digital systems from accelerating and exacerbating inequity. And that's what they will do by default. That will be the default setting, unless we take action, unless we intervene with an eye on shifting that. And so in data feminism, we draw from intersectional feminist theory to outline 7 principles for doing data science in the service of justice. And so I don't have time, it's a short talk, so I'm not going to talk about all 7 principles, but I want to raise some of our questions as they apply to GeoAI. And these are questions that help us address the first principle of data feminism, which is the first step is to examine power. And some key questions that can help us examine power of what we've framed as who questions. And I think they build on some points that were mentioned earlier in this morning's talk by Don Wright as well. So these who questions are super basic. They're who is doing the work of GeoAI, and conversely, who is not. Whose goals and values and knowledge systems are prioritized in GeoAI and whose are not, who benefits from GeoAI, and who is either overlooked or potentially actively harmed. And so if we were going to take a shot at answering these questions, I would personally answer them in the following way, but I'm happy to talk about it. And if I'm wrong, I would love to be wrong about my answers. So in terms of who's doing the work, who's prioritized, who's benefiting, if we're thinking at the organizational scale, right, it's disproportionately corporations and the military who are doing the work, who are prioritized, who are benefiting, right? What are not as present in this work are non-military or non-defense government actors, tribal governments, nonprofit and humanitarian sector workers, public information professions such as journalism or librarians, not to mention, of course, smaller scale community organizations. But if we're talking more at the people, population, or the demographic scale, who's doing the work is disproportionately men, disproportionately white people, disproportionately heterosexual cisgender people, disproportionately global North people. I think we've been hearing a lot about today. Disproportionately Anglo-Western people, non-Indigenous people, elite and expert people who already hold some measure of social and political power. And I'm making these observations is not to make us feel bad about ourselves. I certainly fall into many of these dominant groups that I just mentioned. But I want to make these observations because they point out these are structural barriers for us to be able to realize an agenda around community resilience, public benefit, or racial equity in GeoAI. So the point is that the way that resources and power are organized and concentrated directly inhibits our ability to fulfill that mission. So like our operating environment is working against those goals. So we'll need to be extremely intentional in how we mitigate these structural barriers to realizing a resilient GeoAI. So how do we start? How do we start rectifying this unequal structural distribution of power and resources and know-how in GeoAI? So first of all, like whenever there's structural issues, you have to talk about money, I think. And so from the money question, we need to think about how we can redirect at a hopefully large scale resources towards research and action that prioritizes participation, pluralistic worldviews, emancipatory goals, and the training up of a next generation of public information professionals. And these are folks like planners, urban planners, journalists, librarians, and so on. Folks whose job it is to use information and data in the public interest. And so here I think we can start, I mean, if we have a budget, that's always the question, right? But if we have a budget, we can start by asking creative and applied questions grounded in and driven by community and user needs. So things like, what does GeoAI for the humanitarian sector look like? What does GeoAI for Indigenous sovereignty look like? What does GeoAI for urban planning look like? And I think there's a really good start in thinking about like, what is public interest GeoAI in this white paper that I referenced here at the bottom of this slide on locational information and the public interest. There's a lot baked into that paper. But because this panel is about exemplars, I wanted to provide one. So I want to talk about a collaborative and participatory research project I've been co-leading over the last 4 years, because it provides a ground up and a community-driven model of building technologies powered by GeoAI. So my research lab is called the Data Plus Feminism Lab at MIT. And so here we've partnered with 2 Latin American organizations on a project called Data Against Feminicide. And feminicides are gender-related killings of women and girls. They include cis and transgender women. They are human rights violations, and they are legally defined as a crime in the majority of countries in the Americas, although notably not in the US and Canada, but everywhere else mostly, yes. All governments fail to collect systematic data on feminicides. And so as a consequence, nonprofits, academic researchers, journalists, indigenous groups, and citizens have stepped in to create registries of feminicide at different geographic scales. So some of these groups work at the municipal scale, some at the scale of the state or province, and some at the scale of the country. Our own research project has cataloged more than 180 global efforts that do this work. And so this makes it an incredibly widespread and global form of citizen data science. For the past 4 years, we've been conducting in-depth qualitative interviews and doing participatory design work with these human rights defenders to understand what kinds of tools and data might make their work easier. And so from this work has emerged 2 tools, and I'm just going to tell you about one of them today. So as groups do this work, they are trying to monitor and log every single case of feminicide within their geography of interest. This work is incredibly manual. It's also emotionally exhausting and mentally taxing. They read news articles and they, very literally kind of manually copy and paste details about these brutal cases of violence into spreadsheets and databases. And so in our workshops with these defenders, we developed the idea of a platform powered by AI, which would automatically scan news media articles in the organization's geography of interest, and then send them email alerts for relevant articles. So it's a very similar idea to Google Alerts, which many of these groups had already used, if folks are familiar with that technology. So the key thing that's different from Google Alerts is that behind the scenes, we're passing the text of each candidate article through a machine learning classifier that helps detect whether the article is actually about a feminicide or not. And it has also more geographic precision than Google Alerts. And so at this point, we've launched our platform in English, Spanish, and Portuguese, and we have around 50 organizations using it regularly for monitoring human rights violations. And so just to put a finer point on it here, the development of the platform has been participatory and collaborative from the start. So we've regarded the grassroots human rights defenders as our partners, and we are working in the service of their work. They participated in defining the problem we were solving together, in conceptualizing where AI and informatics might make their work easier, and also telling us where not to automate. And that certainly did come up, and we did not automate where they did not want to automate. In annotating the data that trained our models in different languages, and then finally in evaluating both the models and the overall platform. So those things we did. I also want to say what we didn't do. So we did not seek to acquire or aggregate grassroots data. We did not seek to monetize or own the data of grassroots advocates. We did not partner with an international institution that would have imposed a singular definition of feminicide, since it's actually a pretty contested political concept and it has different definitions in different places, in fact. Instead, we built a platform that accommodates plural, contextual, and intersectional conceptions of feminicide, so that it accommodates variation. And we prioritize working with grassroots groups that are deeply embedded in serving communities on the ground. They have really deep contextual knowledge of their places. So I don't offer this as a perfect example, and there's a lot more I could say about this. And in fact, I do say a lot about the shortcomings of our first models and tests in a case study in my forthcoming book. But I'm offering this as an example, as an alternative starting point for alternative visions of who is served by GeoAI, who participates in building GeoAI, and who benefits from GeoAI. So thank you so much. Here's a number of ways to be in contact. And there's a case study about this project that you can read, where it goes into a lot of the more critical parts of this. I think there's a lot of realities when we do try to work in a participatory and grounded way. There's a lot of on the ground realities that makes such things not perfect examples of utopia either. So, and perhaps we can talk about some of those. Thanks so much.
Thank you, Catherine. Oops. I had me on mute. So thank you, Catherine. We're going to go ahead and hold questions till the end for Catherine, just so we stay on time. So I'd like to introduce our next speaker, Andrew Turner. Next speaker is Andrew Turner, Director and CTO of Esri R&D, Research and Development in Washington, D.C. Andrew develops new technology for open data, civic technology, and geospatial web collaboration. Andrew's work focuses on cross-domain collaboration and democratizing data-driven decisions by creating open tools for cartography and analysis. So welcome, Andrew. Thank you.
Thank you very much. It's great to be here and sharing some ideas and hearing from everyone else's diversity of ideas as well. So I don't think any of us are surprised that AI itself is not new. It's been developing even as digital technology for many, many decades. My own graduate research in the 90s was developing AI for spacecraft for NASA and the ESA, although at the time, nobody wanted black box algorithms to fly in their billion-dollar spacecraft. So those algorithms never flew, but the idea is that this has been going on. A lot of the projects we're talking about have been around for a while, but something is new. Something has really radically changed the vernacular and understanding of AI. And I argue it's accessibility. And this is a pattern that's existed, again, just in the digital world alone, let alone as a species, time and time again. From transistors developed in 1947 to the computing revolution in the 50s and 60s, from punch cards to spreadsheets, anybody could start entering data into a computer and doing analysis. ARPANET to the internet, as we know, GIS to NeoGeography, for anyone that's read those, the idea of making these tools accessible, and now AI in general, machine learning algorithms to chatbots. So once this innovation occurs, it's when the accessibility occurs and starts making it into people's ideas and at our fingertips, that right now, any of you that are bored in this talk or later could be playing with AI at a moment's notice. You've probably played on it, at home with your family or with some kids. I went on a trip recently and had it on my mobile phone as I was traveling around asking questions in the local history of what if you grew up in 400 BC and you just entered the Agora, what would it be like? That's the difference now, is we can access these tools at any moment. So I argue this has been the biggest revolution for AI. It's a simple UI. It's the idea that nothing more than a text interface can now give us access to ask any question we want in the way in which we are comfortable with it. No one had to go and train us on this. We could just pick it up and start using it. And it kind of taught us as it went. And every day, people are exploring new ideas for how to use it, different ways to get recipes and write articles, do coding, all kinds of things. And what's amazing is OpenAI themselves don't even know all the things it can do, yay, black boxes. But what's really changed here is that now in the public, every day, every moment, people are exploring new ways to use this. By becoming accessible, that's where the innovation is occurring and why we're all asking the question, now what? So for ourselves, we look at things like in Geo, our interfaces used to look like this. where you had all these layer pickers and catalogs and menus and toolbars and things like that. And you had to label them and explain them and get certificates on them and things like that. And now it's this. And we're still exploring it. So anything I show is nothing that we're committing to as a company, but you might start being able to do things like in a Python notebook, start talking to and saying, I want to map with these layers and do these analyses, and it starts doing all those things for you. So we're still early in exploring this, and this is why it's a fascinating conversation, what should happen behind the scenes here. But the point is it can, and it's at our fingertips, and you can start playing with this and exploring this now. Within a few minutes, you can start building new tools with it and exploring new interfaces with it. It's really revolutionary every moment. And what's amazing is these will be integrated to other tools that users already know. They won't have to go and learn a new tool. They can do these questions. And this is actually prototypes from years ago in Facebook or in social media systems, in audio systems, even through text messaging flip phones. If you have SMS and you had a phone that was developed somewhere in the last 25 years, you can use AI. So we talked about things like bandwidth for story maps and things like that, or other technologies. And those are rich media, and those provide a lot more information. But now when AI can actually work pretty much anywhere you have any kind of network connection or even offline, you can start having these tools available to you. But of course, we all talk about OpenAI and just a few. And this harkens back to this famous quote by Thomas Watson, that I think there's a world market for maybe 5 computers. I can't imagine more of those. And I think we're here right now when we talk about foundation models. We're like, well, there's only a few of them. We're all trying to make that next one. And there was actually a different way that computers really evolved. And I'll mention this as well, something that transformed this as well. And what's different now is that humans now can interact with the machine more easily. As I showed you, it's not a brand new interface I have to learn. It's one I know. I can just chat to it and use natural language to talk to it. What's also changing now, and why we're going to see a vast proliferation of AI tools, is that if you haven't tried it yet, try and actually hook these two machines together. Having one AI actually learn and talk to the other AI, you don't actually even have to code it anymore. Dawn earlier talked about no code, low code for applications, but now you can have no code, low code for actually interoperability between machines. Maybe this is an end of data standards. I love data standards, but maybe I don't have to go learn a new specification AI. I can just say, here's 4 AIs that bots actually can learn and explore that API and build their own interfaces to them without any human having to be involved. So I just relate to say, I want an agent with these 5 tools and it figures out how to use them. Now, there's a lot of detail there, but the idea is I don't have to go and hard code those anymore. Everyone can have their own. So the better analogy than 5 computers in the world is what David Weinberger said, small pieces loosely joined. So a lot of the conversation here is we keep talking about taking data and services, training them to these big, heavy, as we know, very expensive, very slow to develop foundation models. These are complicated. These are not things right now that we want to go and build lots of. Instead, what's been really interesting, and if you haven't played with things like LangChain or Llama Hub, it's the idea you can go and build very quickly a tool. Actually, the bot can help you build a tool that can tie into live data. So you're not using the old data that's based on the training from 21 or whatever. You're using just that to build out a way in which to use tools and use APIs. And then those can call to live services right now whenever you query it. So it's live up-to-date data. So we can kind of skirt past for a moment that issue of like, well, you're only asking old data, you're only asking the old training, but you're actually using live data and spinning up numerous new tools to both online services, whether they're Wikipedia or weather data or travel data or OpenTable, to private data, data only in my machine, my phone, my computer, and tying to those through secure connections as well, because you can make sure that the foundation model doesn't have access to those credentials. It's just the tool on my machine that's accessing those. And then finally, you can build agents that glue them together to really go back to different custom fit for purpose applications in the broader context, whether it's a general chat one like OpenAI, or it's a history of walking around Greece, or it's a, I need to book a restaurant with my family somewhere over the next week, and we all like these kinds of foods. Those will show up again where you have fit for purposes apps, but they'll be glued together with these kinds of different tools to provide better user experiences. So one of the things though with all these tools, and this is some peppered throughout and I'll summarize at the end, are just some recommendations. So one thing mentioned before here is we need some kind of validation accreditation. So I cite these as examples because they're federal agencies, they're independent research arms, they're both public institutions and academic ones to develop things like ISO certification, green certified buildings. So when you walk into a building, you know it's LEED certified. That means it's energy efficient, it's probably good natural lighting, great place to work. It doesn't tell you anything about the structural integrity of it. It just tells you it's great for energy. You look at other accreditations for other aspects. And I think the same thing applies here as people build foundation models and tools and agents. You want ways to recognize right away that this is the different accreditations it has, and obviously different institutions would define and validate those accreditations. So that's just kind of the basis of AI. Thinking about the question here is now, how does this help us with our resilience? So we have all these great climate-related data and tools. I mention this because this has been the recent discussions over the last decade or so, is that weather and disasters will occur more frequently. So we need to understand climate, build great tools like this built through climate.gov to allow anybody to explore wildfire, drought, flooding. These are great tools, but they tend to be very broad in scale and scope. They're national, they're regional, they don't really help me. How should I move around, or how should I plan my community differently? So what you think about is the feedback loops of a crisis. That the idea of that you want to first be aware of something, that's a lot of the different sensors that governments and agencies bring online. Hopefully you can prevent these things, but you want to be prepared for the disaster, then respond to in recovery. I'm not going to talk about all of these, but it's kind of framing of overall crisis and crisis response. But I want to highlight one aspect of this is the idea of preparedness. So one exemplar that hasn't used AI yet, but this was DHS after 2001 realized that we didn't really know where all the national assets were. Bridges, roads, ice skating rinks, things like that. They gathered up all the data and shipped it around on DVD discs once a year with 2-year-old data to everyone who had signed a piece of paper to say they could have this data. What they realized a couple of years ago was that this data is really valuable for both economic development and preparedness and disaster. The best thing you can do is take all this data and not hope that when the train crashes or the flooding occurs, that someone knows where they put the DVD discs. Instead, they just said, I have the APIs, I have the data, I have the tools, and tools I use all the time. And so they open source this data in about a month because the tools are available for them just to make the data open and accessible. And what's interesting wasn't just this is a now national aggregated set of data sets that's actually curated from local authoritative sources, but they could actually then really quickly spin that up to different scenarios. So this was a few years ago where they could spin up another hub for Hurricane Harvey, another one up for Irma and Maria, where they shared out here the authoritative data for that region. They could crowdsource in new data. And what you started seeing here for resiliency is pre-positioning data, services and tools, and then creating these quick launched applications to help people work around that one response, but powered by those same data and tools. Because ultimately, all disasters are local. Again, we can talk about national patterns and community patterns, but really they're all unique. They're unique this time of year in this community, in this neighborhood with these people. And so the standard mantras have also been that resiliency and preparedness also need to be local. This is in ready.gov. They say, tell you at your family. They don't just say, hey, everyone should have a ladder in their house. They should say, for your house, for your family, make a plan. If you have to evacuate, how do you get out? That's like the hyper local one. But you see that in other communities as well, geographic communities. They partner with local religious groups and nonprofit groups and companies to say, when we need to distribute water, there's no FEMA center there. They use one of the existing centers. They built those relationships with those people to position water. And then in digital resilience, we've worked with communities like crisis camps, where when a disaster hits like Haiti did in 2010, they could leverage thousands of volunteers who've been trained on things like OpenStreetMap and Twitter and other things to be everything from find where people are buried underground, from rubble, to actually being able to map out Haiti because they knew Haitian Creole, and they could map that out in an existing tool for crowdsourcing data. So they pre-positioned a national or global data set for crowdsourcing data they could use in disasters. So what we're seeing now organizations do in terms of this preparedness, and applies here to AI, is that they're defining initiatives around goals and missions, and they're asking them, their organizations, to share this data out. These could be regional councils of governments, they could be national transportation for the nation, they could be around parcel data set, tree data set. You're seeing this happen again and again and again. I mentioned Highfield, that was over 500 initiatives for national data sets, but now it's happening around all kinds of new kinds of data sets. And you start seeing this happen again globally. You're having tens of thousands of organizations' data. And then what they're doing, if you can see here, is they're creating their own climate resiliency sites to share out the data and the tools and the analyses around these. So whether it's in British Columbia, Wyoming, Falmouth, Massachusetts, Columbus, Ohio, Kansas, academic research institutions like Dallas College, American Geo Community, they're utilizing these same ready-to-use tools and data to share them out, understand their own climate resilience, their own preparedness, and how they would respond to emerging disasters. And so we're starting to see the exact same thing now applied to AI tools. So our own Living Atlas is an aggregated set of high quality data and increasingly notebooks and tools for doing spatial analysis and AI modeling. We've heard earlier, if you haven't played with them yet, Hugging Face, which is a great memorable term, but you're never really sure what it is. It is essentially, it is a GitHub for AI models, agents, and tools I mentioned earlier. Llama Hub, another great one. All these great tools. Within an hour or two, if you know a little bit of Python, you can create your own new little mini AI and then share that with other people and iterate on these things. And Kaggle is a great one that has a whole community of people who are talking about their models and data sets and even having competitions. And I highlight these because in order for us, I think, to succeed in these things and talk about all the different nuances of the science behind it, the ethics behind it, is actually engage with the communities who are doing this now and figure out lightweight collaborative ways to experiment with these things, get feedback, and then set better patterns for the future. So these are just a few of my recommendations. So pre-positioning data, orchestrating AI through composition and interoperability, creating accessible, open, local user interfaces, don't make it complicated, and then define ways as agencies and institutions to standardize testing, validation, accreditation of AI models and agents. That's it. Thank you.
Thank you, Andrew. Okay, so we don't have any time for the short Q&A. So we're going to move on to our next speaker. Our final speaker of the day is Erin Burchiaga. Okay, and Erin is a senior practice manager for Amazon Web Services. He's a renowned data scientist, AI engineer, author, and advisor. As a seasoned technology and business leader in both startup and enterprise settings, he has focused his career on delivering efficiency and value through automation, data science, machine learning, artificial intelligence, blockchain, quantum computing, and emerging concepts and innovative technologies. So thank you, Erin, for joining us today and presenting.
Happy to be here. Just quick background on myself, was 12 years an active duty Marine, got my degrees from the Naval Academy and the Naval Postgraduate School, which is how I segued into the fields of artificial intelligence, where I then became a leader at Accenture's AI studios and then a vice president at Booz Allen, ECS, and now AWS, and I have my own company called Data Prime. As I prepared this, I was actually reflecting that a year ago, I was a part on a panel almost the same weekend in 2022. And the topic was the role of artificial intelligence in democracy. And I actually think the same things that we were talking about then are not too far afield from what I've heard my great colleagues talk about today. And I'm really excited to dovetail some of those same concepts in to what I'm going to share with you. I have notes. I'm like Edna from Incredibles. No capes, no slides, all right? So hopefully I can be compelling in some of my inflection and storytelling and not just a bunch of slides, although my colleagues had outstanding slides. So I've divided my remarks today into 4 sections. First off, a basic call to action for all of us. Then I want to share with you some thoughts I have on some key innovations, some awesome use cases. And as I started to write them down, I was like, okay, there's 3. Yep, there's a 4th one. There's a 5th one. Well, now there's 7. So I'll share with you hopefully 7 killer use cases. And then after that, I'll conclude with my thoughts on some responsible AI. It's a series that I wrote in Forbes last year, but is really, really relevant to all the things that we're talking about today now. So first off, a call to action. I think some of the most exciting advancements that I see occurring right now in GeoAI, and my company right now is actually supporting some very interesting research for the FAA at Teterboro Airport with JFK and LaGuardia. Hopefully we'll solve Pete Buttigieg's biggest problems, right? But with that, hyperspectral satellite imagery is giving us huge new opportunities. Edge computing, and then quantum computing. So with hyperspectral imagery, what are we talking about? More data, types of data we didn't know. Ways to measure, ways to count, ways to articulate systems. With edge computing, not having to bring anything back to a warehouse or back to a device, but actually doing that on system and having the immediacy of an artificial intelligence to create a decision or an option that even a pilot couldn't render in such speed. And then finally, quantum computing, having to handle the national airspace, as we will have to eventually. We're going to have to permute. We're going to have to simulate on a sort of magnitude that wasn't even possible months ago. But as cool as all that is, and trust me, I've heard some really awesome, compelling use cases. the things I talked about last year in terms of what's the role of AI in democracy, I think we have to really move from surveillance towards services, right? When I talk to my daughters, I have 3, or when I talk to my wife, they always think, well, Daddy, you're making AI that's watching us. That's making us drive safer. That's telling us to be home. There's this perception by my daughters and by society that AI is here, especially GeoAI, just to watch them. We have to change that, moving from surveillance to services. What kind of services am I talking about? I'm talking about moving from surveilling citizens to fixing flipping potholes. And you can do that with GeoAI. So what are some things that I enumerated last year? They were these. Number 1, pothole repair. Number 2, garbage pickup, especially in New York City. Number 3, field conditions. I have to speed home to get to my kid's soccer game. Wouldn't I love to know that the field was right to go before I got there? Not just by the guy happening to go by and check the field condition and giving a thumbs up. He always seems to cancel the game right before I arrive at the field. Number 4, parking and congestion. And then 5, regular and irregular loitering in traffic patterns. And that one has direct application to one of the use cases that I'll share first down below. So first off, innovation. I think there's a lot that's happening across everything, but I was at Miami-Dade at a supply chain panel just last week, and they were talking, what are the things that you think are, what are the opportunities that keep you up at night? And I don't know if it has direct application to this forum, but I think the third one does. The third one will pop up in any panel I'm part of. I said the first one are cobots, the second one are robots, and the third one is data sharing. And it really comes down to that third one, I think, in any industry and anywhere that you're doing any kind of technology. It's the data sharing, the data blending, the data farming, the data mining, the data wrangling, the data. And what do I mean by that? The layers of imagery, really getting into the vertical fusion of the data that is available. And what do I mean by vertical fusion? We are having incredible opportunities bringing in information from cars and other sensors with LiDAR, moving up through street imagery and other cameras up through buildings, through to drones and then to satellites, literally creating this imagery layer that goes down all the layers of vertical exploration and the information that can be extracted from therein. When you look at some of the other definitions of imagery layers, they include visual, auditory, olfactory, which means smell, gustatory, which means taste, tactile, kinesthetic, and even organic. And I would add in one more that has been most useful to me in almost all my research, and I'm pulling up a screenshot that I pulled from an article just today. Human factors. So visual, auditory, olfactory, gustatory, tactile, kinesthetic, organic, and human factors. And that last one, that's the rub. Let me share this quick quote from a favorite book of mine. I'm sure you guys have read it, The Accidental Superpower. If you haven't, it's by Peter Zohan. Fantastic book. And he says, and tell me if this isn't true. Nothing pushes down, and I'm a second generation Mexican American, nothing pushes down Mexican labor costs, increasing the differential like a drug war raging throughout the country. In fact, the more violent the war, the lower Mexican labor costs. And so greater Mexican American differential becomes the more attractive Mexico becomes to foreign direct investment seeking an advantage in the American market. Now, that's not a political statement, but that is a wonderful way to say, hey, if we can understand the rate, the velocity, the veracity of violence in Mexico from an imagery layer, does that help us understand economic conditions and perhaps what it might mean for the United States? The answer is yes, and it does. So now let's talk about some killer use cases, because this is definitely coming to play at some of the places I've been. Again, ECS, Booz Allen, Accenture, AWS. I'm not attributing this to any one of those employers. But first off, I'm just going to call the client bad guys. All right. So anomaly detection. So what's happening today now, and it can be happening in our cities, and I wish it would happen a lot more for crime or maybe even just a kid missing a bus. But we are able to tell when a package is dropped off next to a truck, and a truck isn't usually at that building, and that building is of important surveillance interest to the United States. Now, this just doesn't happen in the Middle East, and it just doesn't concern us in the Middle East, but I can think of a lot of use cases. The kid that forgot his lunchbox at the bus station, all right, before the, now that's probably not going to be as far as we take it down, but that anomaly detection and that tracking is happening in real and is a great case of GeoAI. Another one happening for Royal Golden Eagle that we had done was looking at forestry, and we have seen this before. But not only at the density of the wood, but also at the health of the wood, and even hunters and the depopulation of wildlife. So marking the movement of animals throughout the forest, and then also attributing that to hunters or not, helped us look at how secure those woods were and how impervious they were to disease as well. Recently had done some work for Singapore. And this was interesting because they were surveilling and taking imagery of ships that were moving through their bays and trying to attribute that to whether or not that ship had a terrorist threat aboard it or not. And I remember staying up really late one night and talking to them and saying, so you're modeling the ships based on how you're tracking them. Again, back to what I said about human factors, you're using the wrong data. As cool and as sexy as it might be to map those ships, you need to not model the boat. You need to model the humans who are driving the boat. Next up, NOAA. So NOAA, we did a study with them recently on fishing and overfishing population. And some of the really exciting information that's coming in, again, getting through all the vertical fusion, the layers of information that can come in. As fishermen are now purchasing their licenses, they are now being told to activate their GPS, almost like a tracking system, like an app-based system that is now real-time monitoring where they are at in the bay, where the fish are being caught. And that is helping us to understand and provide information back to NOAA, both legal and illegal fishing. Again, that is a sort of vertical fusion. For the FAA, runway saturation, looking at the airplanes that are on the ground. When they talk about runway saturation is when there are just too many. A lot of you and I have been paused at airports that the receiving airport can't take us, right? Happened to me the other day when I was trying to go from LA to Denver. De-icing, pushback, and prioritization. And last but not least, my probably very first use of GeoAI in a very meaningful way was during the pandemic. When I was working for Merck and we were helping them come up with a model to understand whether a city was likely to have another breakout or not. They were actually modeling the patterns of humans. We were calling it oscillation. We were basically looking at humans like atoms. And if there was a certain frequency that started to emerge in a city, that led to a direct reemergence of the pandemic. Again, that was a form of GeoAI and vertical fusion of information. So those are some killer use cases. And let me just round out now with some thoughts on responsible AI. If you just type in my name and responsible AI Forbes, the information will pop up. But I thought what was interesting is I go back and I revisit that model every single time. I like the 6 factors that I model out there. And one of them is the title of this workshop. The first is accountability. The second one is impartiality, which I think Catherine spoke to a lot. Who is doing it? Whose goals or virtues are prioritized, and who benefits or is overlooked. Resiliency is the third. Transparency 4, security, and finally governance. I think we'll do well if we think about all 6 of those principles and the technology and the data and the systems we're using for GeoAI. There are some killer use cases. Of all those use cases that I'm most excited about, I'm excited for pothole repair. Thanks.
Okay, so thanks to Manil, Catherine, Andrew, and Aaron for those great presentations. I'll now invite additional questions for all 4 panelists from the committee members who should raise their hand in Zoom, and if they'd like to ask a question. And then for those public attendees watching the webcast, please contribute your ideas into Slido, and we'll work on bringing those into the conversation. So let's go ahead and any committee members would like to go first and ask a question? Yes, Renee, yes.
So this is a question for Catherine, if she's still there, hopefully, and others on the panel. So I am a critic of AI, but I have a critique of critics of AI. So historically, we, especially in geography, we had this sense that there was an audience that we were speaking to. And I think with AI, it becomes quite complicated because of the convenience that AI offers so many people. So we think we're speaking to the same crowd sometimes, I think, when we critique this AI, but actually there are a lot of people who think, no, I think AI is pretty good because it's making my own life, much easier. So I don't know how we balance. So Catherine, you had like who does the AI serve, but who's defining who the AI serves or not? Who's creating those metrics? And sometimes we think we're critiquing from a point when we're actually not. So, the people we're talking about, all of these problems, and people are like, just leave me alone. I love my my Yelp infused AI. Yeah. So what do you think, Catherine and others?
Sure. No, if I've understood the question, I mean, I think, in terms of like who's driving the agenda of AI, I think it's very much a corporate agenda. Like I think it's a corporate agenda that's driven by profit, that's leaping forward all the time, without, with a lack of policy and regulation and oversight. And so in terms of like who's setting the agenda, that's who's setting the agenda. And it's not to say that it doesn't lead to nice things. Like certainly, like there's many ways that people benefit from AI. So it's not to say that we should be like erasing all of our various technologies and achievements and ways of communicating with each other, or ways that technology and AI have like legitimately done service in a lot of different fields. But to note that there's like collateral damage, there's externalities, and there are things that are not being accounted for, and there are actors that are not being held accountable. And the burden of proof, at least as we have it structured today, we don't have a good way to seek justice. If you are harmed by AI, there's first of all like very little way of actually telling that. So there's very little transparency, interpretability, explainability, like all these are good things, but there's like no way of even knowing that. And then even if you do, a lot of times the burdens are on individuals rather than groups. And if AI is doing harm, it's usually doing group-based harms. It's not just like targeting you as an individual. These are harms that follow very similar fault lines, which are fault lines of race and class and gender or ethnicity or religion or so on as the case might be. So yeah, I mean, I think that's how I would answer that question. I think there just needs to be, I would love to see us move to a model where we are more intentional about who is doing the agenda setting, and also who bears the burden of releasing products that are safe, non-discriminatory, and that ensure human and civil rights for all groups of people, and especially the most vulnerable and marginalized people.
Can I build on that? I think that's a great point that you're having. I loved everything that Catherine said. I think for me, in one of those articles that I wrote about impartiality, which I think is what you're really getting to here, is how do we assure that the AI is impartial? Actually, because corporations take over, that's why we can't have nice things, right? But it depends. I think the answer to your question ultimately is it depends. I propose a framework that AI should be unprejudiced, which means I'm sure be independent, meaning it's unprejudiced and it has no personal interest. Number two, that there's a degree of fairness, equitability across all the actors that are considered in the system. And then lastly, context. And I think this one is the rub that we should probably talk about most and debate the most. Context. I think you and I would feel very uncomfortable if the personnel data in this room was used to predict or maybe influence voting patterns or voting districts. That would be an improper use of data, credit scores, gender, race, religion, everything else like that. But will we have any reservation with it being used to explore cures for cancer? So again, I think it all depends on context. And that's where when we create these models and we use this vertical integration of information or horizontal integration of data too, it's all going to come down to who's ultimately accountable across this artificial intelligence. And I don't know if we have those systems wired tightly yet. but I know I'm not the only one calling for it.
If I may add to that, this is Manil. I'm talking strictly from the scientific point of view here, because I come from the Science Mission Directorate here. One thing is clear when I attend these conferences and scientific meetings, it's kind of given that AI has become this universal language, just like the mathematics used to be, right? When I go to a conference, I understand the math side of things because I've done math, no matter which science division or conference that I attend. It's becoming the same thing when I go, I represent our science, but when I go to astrophysics conference, when they talk about AI, I understand what they're doing. So there is this notion of AI being a universal language, right? That's from the science perspective. From the practical sense, when you put that into production, yeah, there's a need for this proper governance and gatekeeping. But at NASA, we have these entities that take these scientific results and work rigorously with the stakeholders who actually use this in the field. And it's upon them to properly make sure that it's doing the right thing and for societal benefits. So I put in a little bit of optimistic view than pessimistic view in terms of what AI can do for us.
Yeah, I think I guess one thing that would be valuable to do would be, I mean, some of the rightfully concerning points of mentioned here, some of them are not AI, many of them are not AI specific, right? They're the use of data to make decisions at scale, to build infrastructure to affect people. So I think would be first frameworks around what is unique to AI itself and what is a general, what other categories do these things fit in? And then with the things that are AI specific, also then, at least I was trying to think about it, is that what is foundational, and the word foundational models, the least way I conceptualize it, foundational models like an operating system, right? They're very core, they're very low level. You definitely want to think those things are abide by general culture, values, ethics. While the things on top of it, as I was mentioning, they're going to get, it's the benefits of software, right? In theory, everyone could have their own apps interfaces that behold to their ethics and their values. It doesn't mean that's good. I just meant that it could be a lot more variation, differentiation between them. So it'd be good to think about, well, again, what's AI specific and what's core to foundation, and then drill into those ethics and values most specially, and then think about the different ones that are either general data versus quote application specific.
Hey, thank you. So we have Hendrik, who has his virtual hand up, and to ask the next question.
Okay, yeah, I had a question coming back to, I think, to Andrew as well as Manil, to the foundation models. And so I'm wondering, of course, we know what it's doing for text, right? For text-based work. And of course, you showed sort of in your diagrams, okay, we go away from individual task-based models to generalized representations. Now, these generalized representations will capture knowledge depending on how you train the data, right? How you do your self-supervised learning. But my question is more, as you sort of envision this going to certain applications, given that the foundation model is supposed to support many downstream applications, how many foundation models do we need? Do we need 1, 2, 10? If we have 100, no, if we have 100, then how is that different than task specific? So how do you think about that? Right? And how do you deal, let's say, then with these complex learning tasks you would have to realize, right? If you not only do spatial embeddings, but temporal embeddings, hyperspectral embeddings, multidimensional embeddings, and how these embeddings depend on each other. How do you think about this? And so I'm just curious.
Well, I can start, I guess. Yeah, that's a very good question. We don't know at NASA when we're doing this research. The approach we're taking is looking at either one domain at a time, or taking one flagship data sets, right? Which we think may encompass a lot of these use cases. And that data set is the data set I showed earlier, the harmonized Landsat Sentinel, which has several bands, but it's optical data, right? Which means that if there are use cases, for example, a use case of tropical cyclone or something like that, which is going to be cloudy, right? If you want to look at ground underneath, that use case is not going to be solved using this particular data sets or foundation model, right? So there you go. There's a need for another one, maybe SAR-based one, right? So we're taking, that's a data set kind of approach. And then the other one will be the actual processes, right? If you want to learn some atmospheric processes for GeoAI, it's definitely not going to be optical data that's looking at land, right? So not two now, not maybe three, but that's a very good question. That's a big unknown. Still, we're trying to learn and see if it learns the processes, the physical processes that's happening by just looking at data representation. So far, some of these downstream tasks, those are very land feature oriented, and it seems to do very good, but we haven't looked at those cases where, but I can tell you it's not two, it's not three. That I can say.
Yeah, so I don't want to go on record saying a number, but I think first it'll be an inverted trapezoid. You know, be few foundation models to many tools, many agents, at least using that analogy. What's also interesting, the foundation models, you can fork them, right? You can take the snapshots and you can use different snapshots. You could fork them along the way. So that's going to be interesting too. It's going to be kind of a fractal dimension, as it were, in terms of number of foundational models. But again, the analogy, I think at least we can frame our thinking around it is, like right now on your person, how many processors do you have and how many operating systems are running right now between your watch, your phone, your laptop, and then looking at the room, right? There's probably a dozen, at least a half dozen operating systems in this room between literally the ones we know about. We think of Mac, iOS, Windows, Linux. There's real-time operating systems. There's embedded ones. There's chips around digital signal processing for image processing, right? You have these specialized ones as you went. And I think the same pattern at least appears like it would apply for AI models, where you're going to have generative text ones, image ones, music-based ones, maybe some, going back to the stuff I was working on, vehicle control and satellite control ones. So you might have specialized ones, but I think you're going to have a few of those big ones, and then a lot of specializations on top of those. And then, at least I predict in the future, you're going to end up having around you 20, 30 AI that belong to you personally, that serve different purposes in your life as you go, right? The question is then how many foundational models are your 20 or 30 personal AIs based on?
Does anyone else want to comment on that? I saw Renee had put something in the chat box as well. So would you like to share, Renee, on that, what you put in there?
Just to say that I don't think any AI is impartial or objective, especially generative AI. Okay, I'm a science fiction fan from way back. And in the science fiction community, AI was always assumed to be symbolic logic and expert knowledge. And in generative AI, we have gone to AI composed of Reddit and 4chan. So I think that's a really big challenge for us. I love the idea of forking, by the way, as long as my forks can be GANs.
Thank you.
I definitely, I don't think I said in the chat earlier, but I think the GANs is a great idea. The idea of testing and breaking things. It's even, I mentioned before, but I'll voice it here around like governments like the census. Census is probably one of the world leaders in privacy protection, right? Under chapter 11, title, which I was with the numbers 13. Thank you. I always get the numbers mixed up, right? The idea of aggregating, very sensitive private data, taking very sensitive private data and aggregate it in ways that are non-discernible, right? Even having to change the boundaries in geography based on that, right? So that's a really interesting technique that agencies like the census could one, just provide out as methodologies, but definitely around, we're not going to tell you how we do it. We're just going to you're going to expose your AI to us, and we're going to do a whole bunch of things, and we're going to help verify whether or not we believe it to also be private and keep that information private. And I imagine those kinds of things we have different, and that's what I was saying, the accreditations is like, an AI would say, our foundation model would say, we've passed these 10 different accreditations based on this version of our model, right? And I think that's a really interesting one for, in the end, it's something that is what standards kind of do. They say, here's what you're shooting for. However you get there, we don't care, but this is what you need to do. And those are kinds of new AI ethics and quality standards that should be defined.
There's been something I've learned about this last year that I didn't think I'm not an expert, but my company's become an expert in, and that's expert determination. And there is a whole industry. There's a whole process around anonymizing data. And like he was alluding to in the census, what LexisNexis is doing across all sorts of patient data so that it can be used for clinical research, so that it can be used for healthcare and other use cases. There's this expert determination process that is probably not as algorithmically driven as we thought it would be. There's actually a rule of three, and I won't get into the details of it, but that is all now starting to be codified and being brought forward for how the data can ultimately be shared. So I think what we will see is you'll see some of these very cottage industries that are pretty primitive get codified and helping the algorithms at least do what's been good enough for humans so far in sharing data to then diffuse it until something better comes along with the AI.
Thank you. And one last question from Dawn. We're going to take just one more question. So thank you.
I hope this will be a good question to end on, but I'm just wondering if it's impossible to be impartial, and humans are flawed, and I think about the best intentions. I think about what happened during the civil rights movement. You know, Malcolm X was murdered by his own community. We hear over and over again about these types of strife within groups or countries or agencies that have the best intentions. So when we try to apply this to AI or GeoAI, and this gets back to our idea of resilience, what are the hopes that things will not devolve or degenerate? In science fiction, I'm still traumatized by HAL in 2001: Space Odyssey. Started off as this fantastic AI and then is murdering. Anyway, what can the panel tell us in terms of how to not go backwards, I guess is what I'm asking.
I'll just wrap up my thoughts with Moses didn't come down with one commandment. He came down with 10. One was not enough, right? And it is by no means enough that impartiality or unbias stands alone. That's why I believe and why I put forth a model that impartiality stands with accountability, resilience, transparency, governance, and security. I think those 6 things, and there's models with 13 and 20 and 3, but I try to create just the right size model of 6. I think those things, when taken in collective concert, will provide some security against one of those things becoming too strong or ignored in the ultimate metering of artificial intelligence.
So we're on the right track then.
Maybe I like that question a lot. I might just end with a thought that may be different from my colleagues, because I think, in fact, we shouldn't be aiming for impartiality, since I don't think that's possible. And in fact, one of the points of my talk was to think about how we cannot be disinterested, but in fact be interested and partial, because if we are not interested and partial in guiding the use of our data sets, we will repeat what they describe. The data sets that we describe produce a world which is full of inequality, and it's full of inequalities based on group-based structural characteristics. And so that will be the world that is reproduced without intervention. And in fact, that's the one that will be exacerbated and like repredicted into the future. And so I think what I would just plant as a thought for us to end on is what is a way that we can bring a reparative lens, an equity-oriented lens into thinking about data and AI and GeoAI in particular, meaning that's a lens that asks us to think on a longer time horizon than just now, this moment going forward. But it asks us to look back in time, it asks us to look at historically speaking, who has been excluded, who has been pushed out, under which circumstances, and how do we prioritize the needs of those groups first. And it's sort of like recentering who should be served. And so how do we take that reparative look and what does that look like? And you know, this might not be for every application area, but thinking in particular those which deal with health and human services in particular. So human needs, allocation of resources to people, and certainly a lot of the ways that AI is being kind of integrated into public sector systems and so on and so forth. Thanks.
Thanks. This is a good place to stop, I think, with those closing remarks. Excellent. So I'm afraid we're at the end of our session. I want to thank everyone for sharing their ideas. I will now turn the floor over to Harvey Miller for closing remarks.
Okay, thank you, everyone. Thank you, panelists. Thank you, participants. Thank you, everyone online. This has really been like an incredible day. I think I've learned as many questions as I did answers. And that's actually the point of doing a meeting like this, to raise these questions and think about the ways forward. I thought all the talks were very clear, by the way, and it's very difficult to summarize this because every talk did a good job of making clear points that a summary almost seems redundant. It does appear to me that there are two major issues that we're facing. One is with GeoAI, how to get it to work right, whatever right means, and how to make it, how to democratize it, avoid silos, avoid tech elites, avoid tech elitism, and avoid implicit biases. And I do want to get back to what Catherine just said, because I thought that was a really good way of describing it. We can't ever be impartial with these methods. We have to be partial and interested. We have to remember that resilience is a classic wicked problem. Probably everyone's heard that phrase before. Wicked problem. And that doesn't mean it's an evil problem. It means it's a very difficult problem. It has inherent trade-offs. There are different groups with different values that will always be in conflict over the solutions of these problems. So we can't pretend that GeoAI or any other technology or method or model is going to come along and make wicked problems not wicked. They're always going to be wicked. It's just an inherent part of it. So I think that intentionality is a very good way to think about that. I want to kind of, motivating this was community resilience. How do we build digital resilience to help create community resilience in the coming era, which we're in right now, where we're going to see more and more disturbances, many of them driven by the climate crisis, the degradation of biodiversity, water quality, all the problems we're facing by human impacts on the earth. So I would suggest that digital resilience requires sustainable GeoAI. And what I mean by that is that, the dimensions of sustainable GeoAI would be that it's viable, it works well, it gives us something close to, I don't want to use this word, Renee, truth, maybe truthiness or some type of facts. It's equitable, it's inclusive, open, democratic, and transparent. And also I want to add that it's green. It doesn't make the problem worse. We don't burn a lot of carbon crunching data and then create, enhance the climate crisis and create less resilient communities. So I think that's some principles that we need to think about. I do want to kind of raise some questions at the end that I think we should all think about. And this was something I think that came out in this last session. Is GeoAI really different than the previous century of scientific modeling? I think of urban modeling, for example. We've had a century of urban modeling when we first started out with these grand equilibrium models that would help us solve the problems in our cities. And that didn't work very well. And then we moved on to agent-based modeling, where we model things at an individual level. That didn't make our cities more sustainable and just. And then we moved into the fourth paradigm of data-enabled science. Still not getting there, and now we're in GeoAI, and thinking that's going to come along. So I'm not saying that, and I don't want to be negative about GeoAI. I'm just saying we got to take a very skeptical look at it, because we've been promised this is just the latest iteration of grand models that are going to solve our problems. And I'm not convinced we're there, but I am convinced we're making progress at least somewhere. I want to touch upon the idea of actionable knowledge. And this is a tension I've noticed in the discussions today. When I think of actionable knowledge, I think that of knowledge that can lead to direct action in the world in a certain place and time. We're going to have to use this knowledge to intervene to make something better, some community better, some place better. There's a tension between that and science, because science wants general knowledge. It wants general principles. And this has been a tension in the field of geography for as long as the geography has been around, for 5,000 years. And we've kind of gone back and forth between general principles, deep description of particular places and times, then trying to reconcile this. It was a real source of battles in geography in the 1980s and 1990s. Geographers did everything but exchange gunfire over, are we talking about general principles or just deep description of places? I think we're now at a point where the answer is both, that we can actually merge these things. We can talk about general principles, algorithms, and approaches that are specific to places and times. And I thought Andrew's talk actually kind of hit upon that really well, where we're talking about, algorithms that are based on scientific principles, but using local knowledge to create, using local data to create knowledge that's specific to a particular place that can help them respond to some type of disturbance or some type of a disruption. We haven't heard as much today about community resilience. And one thing that perhaps we should think about is, can GeoAI give us better insights to what we mean by resilience? Resilience, we can all define resilience, but we talk about what makes a community resilience. Can I look at two communities and say this one is more resilient than the other one? We can say that at a very high level, but to really talk about what are the actions and things in the real world that make some communities more resilient and others not, I think that's a missing domain for GeoAI. And one thing we never heard today actually is what is GeoAI? Is GeoAI actually a thing? Helen Kuklelis, her name came up earlier. She was one of the first people to talk about artificial intelligence in geography. And I remember she wrote a paper many years ago that said, we are really lucky that in English, GEO sounds great in front of everything. Just put geo in front of it, it sounds like it's something. I don't think we're there yet to really knowing whether or not GeoAI is a thing. I think it is, because I think geospatial and geography is a thing, but I think that's something that needs to be clearly defined. I think that's about all I wanted to say for my summary comments. Again, that I think what I'm seeing here in community resilience is that GeoAI can help connect methods and data for local knowledge and action. And to me, that seemed that as the real path forward for digital resilience and eventually community resilience. And in the interest of democracy, I want to ask if anyone in the panel or has any final comments they want to make before we wrap up. Please, Renee.
We also talked about academic responsibility and changing who we tenure, who we hire, what we promote, what we aspire to, what we're held accountable for. And I think we should remember that.
Right. Good comments. And we do need to change our institutional rewards and systems for promotion. I know that some universities, I think Minnesota, Wisconsin, and Carnegie Mellon are now looking at community engagement. Research.
We actually have a Center for Shared Prosperity, and we have a lot of faculty engagement, but the center is run by citizens, not run by us. And if you're involved in that, you get credit towards tenure and promotion.
Good. Okay. I think that puts us on the path towards more engaged scholarship and moving towards a more resilient and sustainable world. So I think that's it. Thank you, everyone. Thank you, panelists. Thank you, committee. Thank you, everyone online. And this recording will be posted on our website within a week. And thank you for really a terrific day.